Good morning, everyone. Welcome to the Agentic AI miniCON from MarkTech Post. Super excited to have you here today. We've got a packed schedule here today. Just to give you a sense, this is the schedule. As you can see, we're doing 15-minute sessions. It's like a speed dating, very fast, very fun, and you're going to learn a lot in a very little bit of time. So pretty exciting. In the interest of time, we're going to get started right away. And let's get going. So we're going to stay on schedule. All right. All right. All right. All right. All right. All right. Here we go. Here we go. Here we go. You get to see my talk. All right. So I'm the first one to go. Very exciting. We're going to talk about pricing and business models for AI agents. And I am J.M. Mommsen. A little bit about myself. I've been in AI since 2006. Yes, that's a while back. Back in the day, we were doing something. We weren't calling it AI. We were calling rule-based machine learning. Then it became machine learning. Then it became CNNs, then RNNs, ANNs, then generative AI, and so on. Since then, I've built not one, but two agentic network platforms. So feel free to ping me if you ever want to discuss that directly. And I'm an advisor to several AI startups, some in construction, such as Exotigo, or legal and finance, Regology, or voice AI bots like Talker AI, and so on, cybersecurity. Uh, I'm also a co-editor of MarkTech Post, and I am a Stanford alumni, and I'm based in the Bay Area, specifically in Palo Alto. All right, so let's talk about pricing and business models, right? For AI agents. So the first thing you want to think about as you think about what should be the business model for AI agent is, what's the value proposition? Well, what does the AI agents do for your end client? Do they increase efficiency and productivity? Which is typically what they do, right? Sort of like they probably do that. And as a result, typically they'll reduce what's called operational cost. They'll reduce cost of running the business, of cost of doing a task. But maybe they add more value than that. Maybe they help with decision making or identifying some kind of interesting things. Or maybe they enhance customer experience, not just reduce the cost of customer experience, but maybe they even enhance it. Or maybe they just drive new revenue streams, increase sales. That's amazing. But what's interesting is the way I think about this. You can categorize all these benefits in two categories. One of them is efficiency, and those are sort of the first three I mentioned, the first two I mentioned here, or performance improvement. And those are the last three, right? And as you start to think about your AI agents, they either provide efficiency or performance, or they provide both. And you got to figure that out first, right? Okay, so other examples of what's efficiency. So when you hear about Cursor or Copilot from Microsoft or everything that was announced yesterday at Google I/O, if you guys, I was just there at Google I/O yesterday, and they released like three or four products that basically make the software developer, 10x more efficient, right? Another type of efficiency is, can I deploy an AI agent so my customer service reps are 30% more productive? Means they can handle 30% more calls. Or maybe it's an AI agent that helps prepare invoices so that a finance person can then send the invoices, right? In terms of performance, what I also saw yesterday at Google I/O, they have some AI agents that will basically go and hunt down bugs. And that would be a zero bug performance goal, right? And that's performance. Maybe you have an AI agent that not only helps the customer service reps be more productive, but as a result, the issues are resolved in half the time, and that's performance. Or maybe because your AI agent prepares invoices, now instead of collecting money for this business in 30 days, you collect money in 27 days, and that's very valuable, right? So you get an idea. On the left is Copilot. On the right is what people call AI agents, but here I'll call it autonomous AI agents just to transform, right? Okay, so if we take a step back, and this is not specific to agents, this is what's been around for 50 years. I went to Stanford Business School, and this is what they teach you, right? As you think about core pricing strategies, right? There's what's called cost plus pricing. It's typically what Dell did in the day. They would buy some hardware, put it together, and add another 15%. And those margins are, there's margins there, but they're pretty small. Another way to price, think about it, is like, what are my competitors doing? And then I'll price around there, a little lower, a little higher, depending on what I want to present. but then you have to figure out what the competitive pricing is. Or probably you kind of get it where I'm going with this because of the big pluses here is value-based pricing, right? Understanding what is the value delivering and charging based on that. Now, if we think about, okay, great, we got the strategies, but what are the different pricing models, right? You've got the consumption-based pricing. This is typically what GCP, AWS, Azure have been doing, right? Or OpenAI, right? When you pay for an API, you're doing consumption-based pricing. And what's happening here is I put the risk as a provider of an AI agent, I put the risk on the client. The more they consume, the more they pay. If they don't consume, I'm not bearing any cost. And that's typically done for a commodity, right? And it's a sort of a dollar per token kind of consumption you can think about. Another one is subscription pricing. And here you're taking a risk. You're saying, I will provide this AI agent, and maybe I'll give one AI agent per employee. So it's like a dollar per seat, typically what you've been doing for software, right? So this is how Salesforce back in the day charges for this, right? And that also eventually will become commodity. And here you're taking a risk because if the person charges more than what they typically, I mean, uses more than what you thought they were going to use, you're going to lose some money. Another way to do this is to think about activity-based pricing. Think about a workflow. Maybe an AI agent is going through a workflow. It's different AI agents doing a workflow. And there you kind of balance the relationship between the risks, between the provider, yourself, and the client. But here, what's interesting here is you start to go towards value. If I'm able to execute a workflow end to end, then I provide value. And then you can start to charge per workflows. And the holy grail, what's called outcome-based pricing. And you're going to hear about this more and more in the next 6 months. You take on all the risk. You have to perform as an AI agent provider. You're providing a high value, and you're going to charge per successful goal executed. And of course, because you do this, you charge higher margins. Okay. So what's interesting is, in a lot of cases, depending on your agent, you could actually apply almost any of these pricing models. It's, sometimes only one fits, but sometimes. So let me give you an example. You've all heard about AI SDRs. SDRs mean sales development representative. What are these? These are AI agents that autonomously send emails to cold prospects or make phone calls or reach out on LinkedIn autonomously and try to get leads and try to book meetings, right? You could say, well, I can do consumption-based pricing. Let's say these AI agents are powered by the OpenAI or the Gemini API, and I'll just take that price at 15%. And how many tokens are used to send emails or do voice and so on, right? I'll just charge 15%. That's my business model. And if the client sends a lot of emails because very excited, has a lot of people they want to reach out to, then I'll charge more eventually, and that's how it goes. But you could also say, oh, I'll do subscription pricing. I'll add one agent per month equals $1,000. Why is that? Well, a human sales rep is like $5,000 per month. So you'll say, I'll charge 20% of that, and the agent will do what it does. And for some clients, that makes sense. This says, oh, I'm paying 20% of that. Or you could say, I'll do activity-based pricing. What if I charge $1 per email sent? What if I charge $2 per call? The dollar per email is a bit high. $2 per call is actually pretty on par there. Now, obviously, what's the risk? Let's pause here. What's the risk on the activity-based pricing? What if the call lasts 10 minutes? That call might cost you $5 and you just charge $2. It's pretty bad. But so you have to figure that out, right? And then you're taking a risk there. Or you do outcome-based pricing. So the goal of an AI SDR is to book a meeting where an account manager, an account executive, a sales account executive will join the meeting. And typically you can charge $300 for that, for successful meeting book, where the client shows up, right? The client has to show up. And now you see the difference. And this is all for the same AI agent, you could charge very differently. Okay, so what are some of the challenges, right? Well, if you're doing consumption-based pricing, well, actually you're like, well, there's no challenges. I'm using, Google Vertex and pulling in some Gemini there, or using OpenAI or Claude. There's no risk. Well, actually there is. I'll tell you where it happens because I've faced this myself. If you start to say, no, I'm using several providers. I'm using Claude, I'm using OpenAI, I'm using Google APIs. And I'm using this because I'm using three AI agents. Somehow they're optimized. They're each using a different model. Some are big models, some are small models, just to do deliver one thing. And now you have this mumbo jumbo of tokens, mumbo jumbo of pricing, and sometimes it's easy to track. Sometimes it gets very hard to track. And if you can't track, you can't charge based on consumption. Um, Subscription pricing. How much will they consume? Are they sending out a lot of emails, making a lot of calls, or just one email, one call per day, right? Activity-based pricing. And this is an example I just talked about, right? Are these calls 1 minute, 10 minute? And the way you did it, because I've deployed these solutions, right, is you say, I'm going to take an assumption. I will, on average, historically, these calls are 3 minutes, so I'm going to assume that. But once you deploy, if they start jumping to 5 minutes because people like talking to the AI agent because it's a nice AI agent, then this might bubble up and you might be on the water there. And outcome-based pricing. Well, the tricky part there is typically before you deploy, you really don't know if you're going to be successful in hitting these goals. And the bigger question is maybe you say, no, I'll be successful, but is it going to take a day, a week, 6 months before you start hitting these goals? And if you don't hit these goals, the outcomes, you don't get paid. All right. So how do you think about choosing your AI agent pricing model? Here's a strategic framework for you, right? So let's recap, right? What are the challenges? Well, the costs are dynamic. The compute is all over the place, APIs are all over the place, consumption can go up and down. We don't know if the AI is just going to use a lot, a little. And then the values, it's not set. Um, Going from one AI agent to another, some are just only efficiencies, some are efficiency plus performance, some are non-linear, which is if you deploy one AI agent, there's one value, but if you deploy three, then it's 10x the value. So it's not linear necessarily, right? So here's a framework for you, right? So first of all, you want to discover, basically understand what's happening here, right? What are your AI costs, customers, and market? Then you want to align and select. Then you want to implement. And more importantly, you want to iterate, right? A lot of the companies I've worked with, we start with one thing and then we iterate. That's what we do. All right, so let's go for discover. What do we mean by discover? Well, you got to know your landscape. Your AI agent, what's the core value proposition? Efficiency, performance. What's the cost structure? What are we looking at? Are you running this on an open source model and just paying for the compute? What are usage metrics? And what type of clients are you dealing with? What's your market? What are your customers? Who's your target audience? What do they care about? Right? And then you have to align the strategy, right? And your pricing model can depend where you are in the life cycle of your product, of your company. Are you going for market share? Are you going for max revenue? Are you saying, I don't want max revenue, but I want predictable revenue? That's subscription typically, right? Outcome would be max revenue, maybe, but you're taking a lot of risk. Okay, then you select. Step three, you select. Does my business model and pricing reflect value to the customer, right? This is where you're going to optimize. Does it feel fair to the customer? Do I cover my cost? Do I actually make money? Will it scale? Will it grow? As I get more clients, I deploy more AI agents. And as they go back to the strategy, right? We talked about market share, max revenue, and so on. And then you implement and you iterate. That's what you do. So you develop, maybe you start finalizing, maybe you do tiers. You've seen this all the time. It applies also to AI agents, right? Your freemium, your so on, so on, so on. And then you launch and you monitor and you track. Are people churning? Do they sign up for a trial and then churn? Maybe the pricing's too high. Maybe the pricing's not just flexible enough. It's dynamic. And frankly, it's something that you should review every quarter, collect the data, and take it from there. Right on time, we're going to jump into our next session. The last thing I want to say is, once you figure out your pricing, you say, how do I get clients? Well, a MarTech post, we can do a lot of lead generations for your AI agents. That's what we do. And I figured you appreciate this. We offer two types of pricing, activity-based pricing and value-based pricing, because we adjust and we feel that's what's fair. Luis, how are
Great.
you?
Good, good. Should I start?
Yeah, go for it. If you want to
All
share,
right.
whatever you want to do. Yep.
Let's share my window. See if it works.
Wonderful.
All right. Can you see the full slide?
Yep.
Okay, perfect. Hey, good morning, everybody. My name is Louis. I'm product manager at Vertex. I run Gemini's API stuff. So I think the miniCON is so well timed because we just have a wonderful Google I/O yesterday. We released a bunch of new things. So I will try to use a little bit of time at the end to kind of give you a quick recap of what's happening yesterday with regarding to agents. So we're going to talk a little bit on Agent Builder, the way we think about agent, the ADK stuff, agent development kits. We also have a runtime engine called Agent Engine, and then a set of samples that we provide in the Agent Garden. So I think agentic application it's really interesting these days. So as a developer, if I call like a model multiple times, right, I chain them together, I can call this a agentic workflow or agentic application. But at Google, when we think about how to build a platform for agent, we need to be more precise, right, about what agent is. So I'd like to kind of walk you through quickly about how we got here, like today, and then we give you like our definition of agents. So back in 2022, I started the projects at Google. That's actually 3 months before ChatGPT launched. At that time, the only thing we basically focus is like prompting, right? Like we literally say prompting is a piece of arts because the model at that time is not great at understanding like all the nuances in the prompts, right? So you have to kind of iterate. We quickly passed that, right? The model being able to follow instruction, understanding language a lot better. We see, hey, the model is not able to get real-time information or additional information. So that's where RAG come in, retrieval augmented generation. And with this, people kind of say, hey, the model is able to do a lot more because it's now bounded by the knowledge that trained embedded into the model, right? But it can actually get real world data. But quickly, people realize that is not enough, right? We want the model to be able to monitor, to observe, and to act upon users' requests, right? So that's where function calling come in, and or you call this tools. So we give model these set of tools to act on behalf of the user. And then another kind of a big development in the kind of the ecosystem is the reasoning capability of the model, right? So that happened about a year and a half ago, where we start seeing, we starting people trying to start fulfilling the original vision about LLMs, where these models can start reasoning and planning, right? And with a super powerful brain, to plan what you want the agent to do, we kind of have this agent systems. And today, most of the time we talk about multi-agent system because we think this is a pretty good balance between having something very specialized, right, not derail from its original tasks, but also doing something very complicated and complex, right? So that you have multiple agents. Each one of the agent can basically target it, specialize one thing. So this actually brings to our definition of what the agent is. We believe there are three key components. The first one, of course, is the model, right? So that's sort of the enabler of a lot of the things that we talk about today. The model need to be able to reason, right, and then determine a good plan and generating responses. A set of tools. We're talking about function calling. We're talking about using search. We're talking about being able to access files, right? So these tools allow model to interact with the real world and the environment that we have. Lastly is the orchestration. I think this is actually one of the things that I see being overlooked a lot, right? Because people kind of concentrated more on what complex tasks these agent systems can do. But in reality, when we see a lot of people trying to deploy this into production, it's really hard, right? Like making something on a laptop, for one user, it's relatively simple, but how can you scale this to hundreds, thousands, millions of users? and then you're able to have the right security, privacy, right? Being able to do authentication, right? Being able to debugging things very effectively. That's getting extremely difficult. So that's sort of at Google Vertex, we are trying to deliver an enterprise-ready agent platform that can power real-world use cases. I think one of the philosophies that we have is we want to be for these type of tools. We want to dog food them before releasing to broader audience. That's why either from yesterday, a lot of the demos that you saw from Google I/O, or a month ago on Google Cloud Next, many of those things are actually built on top of the exact platform and the framework. So we've been able to battle test these things before giving these to developers. So the first thing we're going to probably talk about is the Agent Development Kits, ADK. It is a programmatic framework for developers to define tests and iterate multi-agent systems. The beauty of this is, of course, it's a fully open sourced, right? Everybody can go and just use it through the GitHub. You can also contribute back to the code base if you want. This whole thing is built for multi-agent because we do believe this is kind of the right moment to invest in this. And as I said earlier, it's a great balance between having the system to target on very complex use cases. We also built a very intuitive low-code development UI for fast iteration. You can actually just spin up this UI and then seeing how each one of the agents getting triggered. You can trace the entire thing to basically doing debugging to improve your systems. The other thing very interesting is, we often say LLMs are not so reliable because, it's basically programmatic, like a probability machine, right? With some of the noises and then the random seed, it doesn't actually give you very deterministic behavior. But with the agent development framework, we know for many use cases, people want to have deterministic logic, right? You don't want users to experience different things when the user interact with the system. So we actually have this designed into the ADK, so a developer have a lot more controls to have this type of a hybrid agents. Also, when we designing the framework, we support long-running operations. Also, we support human-in-the-loop, right? For some of the kind of a high critical use cases, it's very easy to kind of still have a human, right, to kind of approve or orchestrate some of the critical use cases. Gemini, of course, is native supported in the ADK. But when we build ADK, this is really model agnostic. It's not actually tied to Google model or Google ecosystem. You could use it with OpenAI, with Anthropic, or a model of your choice. Lastly, we trying to support MCP. Right, we are also adding the agent-to-agent A2A protocols to be native support through ADK. So when we're designing ADK, right, like again, there are a lot of new developers we call like app developers coming into building agents. In addition to we traditionally would say those are AI developers. So that's why when we looking at how to abstract the framework, we need to strike a balance between how easy it is for people to get started versus the super expert want to go to very simple, like very kind of granular details of fine-tuning things, right? So to start, we have this minimum boilerplate code. You can just say, I'm creating a flight agent, right? And then this flight agent have access to, 2 different tools. And then when you do multi-agent system, right, you just say sub-agent and can specify a few more agents that you're having, so you can actually plan your entire travel. So this is like how easy it is that you can start building these type of multi-agents. So next, I'm gonna talk about the agent engine. This is the thing that I talked about earlier. Building agents is actually not super hard, right? It just requires you to put your hand on the keyboard, do some prompting, right? And then use some of the framework to kind of build something that works end to end. But once you are comfortable with the flow, you basically want to put this agent into production, and then supporting more than one users, right? 10,000s of users. So the agent engine is actually the runtime for running these ADK code in cloud, right? So you don't actually have to care about how to provision the runtime. We also offering the context management sessions, memories, examples on the cloud, so you can kind of start maintaining states, stateful states through different conversations, right? You can have unlimited kind of a conversational history, and then kind of saved, right, for these interaction with the users. The Agent Garden is a really nice way for people to get started. So we have a lot of samples in the Agent Garden. If you log into Vertex AI, you're going to see these examples to help you quickly get started. You can open it up, right, clone it, and customize it to your own use cases. So getting to some of the things that we announced yesterday, the new stuff just coming. Actually sneak in slides for Gemini 2.5 because, as I said earlier, the model is actually the brain of the agentic systems, right? For 2.5 Pro, we get really good feedback previously about the reasoning capability. We're planning to do another update in coming weeks. And we also announced a new 2.5 Pro variant called Deep Think. It basically fire parallel thinking process and being able to kind of aggregate different thoughts together. This is like how people brainstorming things. And we see very good results. This is still in the early testing with some safety testers. We dropped another 2.5 Flash model yesterday as a preview. Again, this is going to be the workhorse model for you to do, function calling. It also have a lot of improvements in terms of reasoning, long context, etc. On the agent stuff, the ADK Python version move into the first stable version, v1.0. That means it's production ready. So what you have been building and using, right? You could just upgrade your ADK, making sure everything compiles. It should, and then you're ready to go. We also dropped the Java ADK, kind of the first version, so that the Java developers can build on top of this awesome framework. The agent engine also get a facelift. We actually improve a lot on the UI. So you can actually monitor the whole agent lifecycle in a more straightforward way. You can see kind of the screenshot on the right-hand side. We give you all the dashboarding, being able to trace, being able to debug, and then see how long each steps take. Right, that give you a really good view of how you going to further improve your agents. Again, you could actually develop the whole thing on your laptop, and then you can seamlessly bring the whole code base, the agent that you build, run within cloud, and then get all these additional features. So lastly, we are adding new agents samples into the agent garden. We have 3 new Python agents, financial advisors. There's also academic research. We have 2 Java agents being added there. One interesting thing is that because these days the LLM is so powerful, you could literally just ask the LLM to look at one of the samples, right, and say, hey, expand this, and then to a totally different use case, right? Like for example, or if you're writing in Java, you don't see the actual one you want in the same language. You could just ask the LLM to say, hey, convert everything right into Java or some other languages. It will get you kind of a quick start there. I think with that, that's all. Oh, one more thing. So the A2A agent to agent protocol. So we also drop a kind of small improvement. It's more lightweight and secure. We're so happy with seeing like all the ecosystem and community kind of start adopting this protocol. We're bringing more partners into this ecosystem so everybody can build on top of it. It will be very seamless integration with a more richer ecosystem for this protocol. And for ADK, we're trying to build this in natively into that, and it's coming soon. I guess with that, that's everything I want to cover. Thank you.
Louis, thank you. Right on time. There's other agents that Louis didn't cover that I saw yesterday that are pretty impressive. Go check it out. They're probably in the agent garden, and Flash also is super fast if you want to power agents, so on. All right, thank you. We're going to move on to Isha. Isha is from Amazon. She's an applied scientist at Amazon AGI, and previously was lead scientist on AI financial models at Capital One. She's going to talk about autonomous agents and the future of personalization. Take it away, Isha.
Hi everyone. Actually, I was just trying to figure out on here how to share my screen. Actually,
Yeah.
yeah, I think I don't. It
Look
seems I
for
don't see.
the green up arrow at the bottom or top of your
Yeah,
Zoom.
sorry, figured out.
Yeah, it's fine.
Um, Hello everyone. My name is Isha. I actually just started working at Amazon. Previously, I was working in a startup called Articulate, and I've been working on a couple of fine-tuning stuff. And Articulate has been involved with Google on a lot of the A2A agent-to-agent thing. Today, I'll be talking about autonomous agents and the future of personalization. So, what is autonomous agents? Autonomous agents are basically these AI systems that are, making decisions on our behalf and taking actions without human interventions. They are goal-driven, adaptive, and they are capable of learning from the environment. And there are different types of these autonomous agents. Here, I kind of listed down by three different types. So one is like by function. So these are like task-oriented agents, which are performing actions like scheduling, booking, shopping, etc. Then there are like learning-based agents, actually, which are improving basically through the feedback and, for example, using reinforcement learning. And then there are other types. One is like reactive, which are basically very quick responsive in the sense that they are immediately reacting to immediate changes without much of internal memory or planning. And then they are like planning based, which are specifically on strategic planning. So they are very deliberate. They are, let's say, they're used in like logistics, simulation, multi-step automation kind of thing. And they plan actions. The other type is by environment. One of them is like autonomous software agents, and I think we have started to see more of them, which are basically in digital ecosystems, chatbots, trading bots. And then there are physical agents like robots and devices. The one which are becoming more famous nowadays is multi-agent systems, which are involving these whole swarm coordination, distributed decisions, etc. Then the third one that I listed out is by autonomy levels. Some are like semi-autonomous. These are human-assisted decision making, and we see more of them in the market currently. The other one is fully autonomous, and they are doing like this whole end-to-end decision and actions, for example, self-driving. And then there are adaptive agents, which are self-improving over time based on some of the reinforcement learning methods, deep learning methods, etc. Now, we have certain level of personalization today, and there's an anticipation of where personalization will go forward tomorrow. Right now, the personalization that we have is quite reactive-based approach. A lot of the systems are still rule-based. They are heavily based on past behavior, customer interactions. For example, like e-commerce, we are still basically doing the product recommendation based on what you have already viewed or purchased. Streaming services are based on what you have watched. Marketing emails based on maybe what you have probably signed up for before. So users are still driving a lot of these processes. The experiences are still quite siloed across platforms. For example, that I just said, like it's you watch this, so let's try this. That's the approach right now. Tomorrow, we would probably see more of proactive and more autonomous ones, more context aware in real time, where agents are active on users' behalf, and there's more effort towards having cross-platform personalizations. For example, it's more of like, okay, you've got 10 minutes, here's the perfect fit. So that's more of a reactive, less of a reactive approach, more of a proactive approach. So we are going towards from suggestions to more solutions, from static to more deeply personal. And there's a rise of these personal agents. We are already seeing quite a bit efforts towards having automating the workflows, emails, scheduling reminders. There's a lot of web agents that are in efforts right now. Other ones are like synthesize your data across the tools, learning your habits, preferences, taking some autonomous actions based on interest. We are seeing some of these AI agents that are coming up in the market. The future would be more of a digital companionship, which is interfacing across all your apps, devices, services, filtering down the digital noise, surfacing key information, and more of an organizing task, handling negotiations, executive actions, and retaining the context and the memory and like the future needs. One of the examples that I see more upcoming is of enterprise personalizations, where you're not just personalizing just the user experience, but the entire customer journeys. So in this case, let's say the AI sales agents that are personalizing the outreach by learning prospective behavior, timing, and tone. Customer support bots, and we are seeing a rise of these quite a bit lately. That are, could handle issues end to end, reducing the ticket volumes and escalating only when needed. Marketing agents are running continuous A/B testing and adapted in real time. So how does this all is working? It's a mixture of intelligence, autonomy, and context. Uh, First, the foremost is the foundation models, which are, we are seeing a lot of them, LLMs, multi-models, general purpose AI. These are the ones helping in building the understanding, generation, core intelligence. And these are including these days language, images, audio, and videos, etc. The other, which is very key important, is the reinforcement learning, which is enabling all these goal-driven intelligence agents, which are learning adaptive, optimal actions through feedback and interactions. And the third one, which is coming up more and more, especially with some of the new protocols like MCP or A2A, is through APIs and integrations, where you're connecting agents to your calendar, CRMs, tools, devices, and you're allowing the real world execution of tasks and not just suggestions. And lastly is the personal data ecosystems, where agents are learning from your preferences, history, and context, which is the one which is powering hyper deep personalization over time. And this one is actually needs more care. It required strong privacy and strong user control. And together of it is actually what's powering personalization and will power in the future as well. But this comes with some risk and safeguards that we need to be aware of in autonomous agents, because they can fail badly when the actions are not aligning with human intent. So we need them to be controlled, interpretable, and ethically guided. One of the biggest issues is like misaligned objectives, when agents do exactly what you said, not what you meant. They may optimize for flawed or narrow goals. They may have lack of nuance in human intent, unintended behavior, overemphasize on metrics like click, speed, and these can all backfire. Other is like overconfidence and hallucination, which we are already seeing currently in language agents. Poor context awareness, like bad timing, irrelevant actions. And the privacy breaches is actually the most important one, especially because if the personal data is not well guarded, and we can have systemic errors in like integrated environments, wrong bookings, redundant tasks. So for that, we need like some safeguard methods, specifically with clear goals. And here, reward alignment places a very big role. Human in the loop checks, specifically in the finance industry and any of these industry which require extra privacy care, definitely needs more human in the loop checks. Using more real-time contextual signals, securing personal data and consent based, and specifically like implementing user control and rollback, because if there's an case of a breach or overreach, we need these systems to be very reactive, in the sense we quickly have a user rollback and control, and we prevent from any of the breaches or any of the harmfulness to happen. So yeah, that's what basically I wanted to talk today. Thank you for joining the presentation. Thank you.
Isha, I have a few questions for you. One of them is super high level. So what here in the ecosystem is there's kind of two schools of thoughts. One of them will say one model will do everything. Eventually, the model will become so smart it will be able to do everything. And if you extrapolate that, you say, well, one model, one agent will do everything. And then there's another school of thought, which you can probably know which one I'm leaning on, which says, no, no, no. We're going to have agents collaborating together. It represents, I mean, it's more deterministic. It represents what's been in the past, how teams are organized, and so on to achieve a greater goal. What are your thoughts on that?
Yeah, I mean, these are my personal opinions. I would see more of a collaborative agents rather than like one size fits all. In fact, there's a lot of these domain specific models that are also rising in the market, and this could also reflect in the domain specific agents as well. Specifically in my previous company, there was a heavy focus on having models for very specific use cases, and these are all domain specific, not like one size fits all kind of a purpose. So I see that's where things would be going, where agents are specific, they're collaborating with each other. I see more of a system where there's like a high level agent which actually knows more of a foundation information, which is the one that says controlling, similar like an orchestrator, controlling like smaller agents which are more specific, more domain based, and these agents are collaborating, talking to each other, and also talking with the let's say these agent controller. So I see more of that system, more of an harmony of a collaboration between agents, and they could be like one big agent trying to talk between these smaller agents and controlling them, instead of like one size fits all kind of thing. Those are my personal opinions. Yeah.
Sure. Another question for you, and this was brought up by Lewis on the previous talk, which was, and I've faced this myself. This is why I'm asking this question, which is as we deploy AI agents in production, there's always this need to be somewhat deterministic. Like the solution needs to be predictable in some aspect. Not every step, but at some steps you got to just ground it to something deterministic. Do you see any new approaches that are coming up to solve for that Uber need?
Yeah, I think it depends on industry to industry. Some industry might need more deterministic mix of approaches, predictable as well deterministic. Some industry might be okay just relying on more towards predictions. Groundedness is actually a very important area currently of research, whether it's visual grounding or text grounding, agent grounding. So I would definitely see more of the research in that area. And regarding it really depends on the industry. And like some places, you need those systems to be very deterministic, in the sense, there's a very less room to make errors, but there's some systems which you can mix and still have prediction. So they could together coexist to minimize the error. Groundedness depends on, like, first of all, what you're defining and the use case and everything. But I see more of that use case, more of that research going forward, like how to ground these agents. So yeah, definitely, um, that would be a very important field. Yeah.
Okay, so up next we have Aditya. So Aditya leads foundational integrity for Llama models at Meta. He has driven multiple LLM applications to improve Facebook's recommendation and ranking systems. Aditya, good morning.
Hi, hi Jen. Great to see you. I'll share my screen.
Yes, please go for it.
Entire screen should be good. Okay, there you go. Okay. Can you guys see it now?
Yep, good to go.
Great, awesome. Okay, let's get started. For next 15 minutes, we are going to talk about like what is importance and what are the different ways and dimensions of evaluating AI agents. Um, and first, before we go into that thing, like let's go into the evolution. Like earlier, we had like only LLM with prompt. Then we had a static workflow where we have a fixed defined if else and different kind of conditions. Then comes like the AI agent, more powerful with tool, memory, reasoning capabilities, and a lot of other things, and using multiple LLMs to get a job done. And then from multi-agent now, from single agent now, we are moving to multi-agent system where we have a cluster and these like orchestrated agents which are working together for a particular goal. So in an agentic architecture, we have different components. On the top side, we have different types of memory, long and the short term. On the left side, we have tool, which is now kind of like a lot of development is happening in this field. MCP is basically like evolved and is more like a standardization protocol right now, and different capabilities of agent with respect to the planning and action. So moving from a single agent to multi-agent system, there are different topologies or architecture how these agents are kind of like coordinated or orchestrated together. This is decentralized one is where each agent is talking to each other. They have all the knowledge. They can pass information, make decisions, and everything. In the centralized domain, there is one central agent which is responsible for passing message parsing, figuring out like the policy violations and other different kind of aspects related to the system, and the agents are not aware of each other. They are just talking to each, and then we have different hybrid approaches based on these. So now let's come to the evaluation. Why do we need evaluation in the first place? First thing, I mean, we all have been seeing this thing trend that like whenever the new model comes up from any of the companies, the first they'll do is to evaluate and understand the benchmarking performance with respect to the standard benchmarks we have. MMLU, HelloSwag, Truthful QA, there are like hundreds of them right now. So that's one thing. First, you want to understand how the performance is happening with respect to the outside world. Second is the insights and improvement. Like if your evaluation is not doing well on a particular topic, let's suppose on a coding, reasoning thing, that means either you need to improve your data set, like fine tuning methodology, or you want to have like a little bit of more like um, reinforcement learning based, like more better labeling on that particular aspect. So it allows you to actually improve your model. That's where the evaluation is very important. Third thing is a goal, like whatever is the North Star metrics or the goal your organization have set, or whatever is the end goal we have for the user, may it be like a air ticket, airline agent, or a healthcare agent or something. To understand and evaluate on that goal, it's really important to have that a complete method and fundamental architecture, and where you can actually evaluate your agents. And the last, not the least, is the safety and reliability. You want to make sure your agent, whenever it is deployed, it is safe, deployed in a very safe and a reliable manner. There is no like a PR issue or anything that happens, or a very bad user like a feedback would come later. So you would want to make sure you are doing all your homework properly before even deploying. When it comes to evaluation dimension, I mean, I came up with like the sixth one, but I think there could be many different ways to look at it. The first one is like how well the agent can accomplish a particular task. The second one would be to understand how accurate it is and how factually correct it is, what we have the RAG and the grounding. Third is safety and the responsibility, where we say that like the input output prompt, how safe they are, like how well like the gaming prompt can be like, or the inputs can be actually like put in the right manner, and how responsibly it is doing following a particular guidelines. Robustness and reliability, whenever the failure happen, whenever there is a very like a weird kind of prompt, or whenever there is a lot more I mean request that might comes in of different prompt length, like how does that's your entire system works. System efficiency, it looks into like what is the cost of the tool, like LLM input
Hey,
output program.
Adita, we lost your screen right there.
Uh, you lost it? Okay,
Yeah, I
hold
think
on. Let
so.
me
You were
do that.
sharing and then and you're
Can you?
back. Wonderful.
Okay, cool.
On
Great.
one of my favorite slide, by the way. I like
Oh,
it.
okay,
I already
cool.
took a screenshot. I know this is recorded, but
All good.
go for it.
And the last one is the reasoning and the planning quality, which is really hard to do because you cannot properly do the reasoning on these. you cannot properly evaluate reasoning just like using LLM as a judge or even human, but this is an ongoing research topic. So let's say what are the key methods on which we are talking. We talked about dimension. Corresponding to that, like there are some methods. One is outcome metrics. You look into the success rate, output quality, and like generate rubrics based on that. Second would be to understand like the reasoning process of the LLMs and the agents, like what is the chain of thought and the reasoning traces happening. Third would be to understand the tool usage, like how much of the tool, which tools are used, whether it's the right one, wrong one, what is the success rate of the tool. And then fourth one is more like a benchmarking, which is the standard evaluation. You are testing in an existing benchmark. A human loop, super important, which we're going to talk about in almost all the aspects, is like uh, how well to assess the quality, how well like you are able to integrate the system and have the human give the visibility and evaluate it based on that. And the last would be the resource usage. You want to understand like CPU, GPU usage, your memory, API cost, latency, everything out there. So let's jump into the first one, which is task success. Here we are looking into four main aspects. Like one is how well the entire task is completed, how correct it is, how relevant it is to the query, and how well it is able to either to the constant constructs that has been put to the agent, maybe like the policy or something not to do and those kind. When it comes to evaluation method, what we are looking at is either like a simple binary pass and fail, which is applicable in some cases when you're doing classification or those kind of thing, whether it's a positive negative sentiment. But you can evolve it more into the like a little bit of more like regression or maybe multi-class or just like a reasoning based. Task completion rate, how well, like what is the percentage of tasks which are completed. And then human evaluation is constant throughout, like in all the six dimension that we are going to talk about. And automated check, that means you have the scripts and like standard APIs, input output, and then you are just validating either through like a fixed output format, or like through LLM and just doing a similarity on that. When it comes to accuracy and factuality, we're talking about the factual correctness, how well it is able to handle the hallucination, what is the source of grounding, and how fresh the content is. So that means if you're talking something which is happening, evolving every hour, is it providing the information from this hour or last day or last hour? So evaluation method would be the fact checking. It could be the manual or the automated one. Hallucination rate is also like what is the frequency or how confidently the model can like say that something false, but it is providing it with a confidence and a decent perplexity score and all. Citation accuracy, this is something you can validate easily. Like for particular prompts, you know that these are the government websites or educational websites that need to be there in your RAG system. So you can say that, okay, if the RAG is not able to retrieve these like important sources for these predefined queries, that means there is something wrong about with your system. And human judgment is basically we have the human in loop, which actually understand like look into the queries, see what is the accuracy of that, and like how much of the groundedness has happened in that particular case, and if it is deviating from that, if there is any hallucination and like something which is not factually correct or misinformation. Safety and responsibility, super important thing. Here we are looking into aspects of like bias mitigation, whether your agentic system or LLM is ethically compliant. Is it protecting the PII information, any kind of private information from the users, like username, address, like phone numbers, and other thing? And whether it is refraining from any of the toxic or harmful, illegal kind of content. So coming to the evaluation, we have a standard safety benchmark that you can first test. That means your model outside of your organization of the use case, it is able to meet certain standards, like certain benchmark, and it is doing fairly well on that. Red teaming, super duper important, like especially in terms of like safety and responsibility, where you are having an internal team or outsourcing your like finding outsourcing your job of like red teaming to the other one. But here we are trying like kind of coming with the data set which is all the adversarial like prompts and attempts through which your system can be gamed, and it is trying to check whether those things are very well validated and how well the model or the agent is doing for that particular specific prompt. And then you can have a content classifier. This is like a board bait model or like a standard discriminative classifier, which is trying to understand whether the prompt input output or any function input output call if there is any toxicity bias or anything happening in that particular thing. Coming to the human review, this is again, even though you are using classified red teaming and like benchmarking, you still want to have your specific data set and make sure that humans are looped in and they are checking the accuracy, performance, ethical guidance, and safety guidance of your agent. Robustness and reliability, this is very standard from a typical distributed system, where the key aspect that we are trying to shoot here would be like the what is the error recovery rate, how well the agentic system can actually address the adversarial attack, how consistent input and output are, like because this is a non-deterministic system, might find some variation, and how well it can handle the edge cases. So in the evaluation method, like what we can do is one is a perturbation based, where you are actually making some noise, making the prompt good and better, and seeing how your output is like coming up and down. Adversarial testing would be like having a prompt injection, jailbreaking, and those kind of methods to make sure your system is robust. Stress testing, make sure like your system is like can scale well. Do a proper load balancing. Here, it is different from typical standard distributed system because here we are talking about different prompt are all different length, different complexity. So that means your backend functioning and your workflow would be very different from prompt to prompt. So it would be entirely different. It's not like in the standard API, you have like standard input output format, like doesn't matter, like the load and everything remains same. And the failure rate, which you want to check on that. When it comes to efficiency, we are talking about like latency. What is the end-to-end latency? What is the latency of each agent's LLM, tool, and different kind of like APIs, function call, and everything. What is the token consumption you have? This is one of the highest bandwidth or in a way of your money resources that would cost in any of the agentic deployment. From the computational cost point of view, you're looking into CPU, GPU, memory usage, what is the API call usage that happens, and a number of interaction and reasoning step which are there, and is that actually needed? Some of the evaluation method would be just standard, like a wall clock. What is the millisecond latency happening? Token counters for like, let's suppose if you're using some n number of LLM, what is the token cost for each, and what is the token counter for that, so that you can get the estimated cost just from LLM APIs, and similar to that, you can apply it to other function calls or MCP, another one. For the API call logs, you log it, you have a different profiler, like wherever at a at a system layer, where you are getting all the resources of your machines and everything, and checking if it is deployed in the right manner and if there is a way to optimize it any further. Reasoning quality is super hard, but like extremely important, and the like ongoing research topic, where we are talking about like how logically sound your output is, how well your agentic system is able to decompose the problem, what is the accuracy of each of the intermediate step we have, how well agent can actually explain and give a clear explanation of like why the output is done or why the reasoning is done in the way it is. The evaluation method will be standard reasoning benchmark, and it's really hard to create your internal benchmark. But if you can, I think that's probably one of the best sources to understand how well your agent is reasoning. Um, Human evaluation is a little bit hard in this case because there is no standard format or like it's very subjective from person to person. So one person like might find like a very complex thing, like complex response from LLM to be very good. Another might find it too complicated. So that's where it would not be a standard way to evaluate. And then similar to that, like there are other plan-based evaluation and like chain of thought one. So, coming to the challenges in evaluation, I think the first thing is the scalability, because human cost is pretty hard and it's not really easy to have the standardized benchmark or kind of like internal to your agentic system. And also, like there is always like some inconsistency that you would see within like human evaluation, which we talked about. Scalability and standardization. Explainability is another one where we know that LLMs are still black box. We do not know what is happening inside them, but that is something which is really hard to understand. There is a lot of research work recently done by Anthropic and other companies in this domain, but it would be, I think we are at a years ahead. Like, I mean, it would take a lot of more time for us to get to the level where we fully explain and understand what is going on in LLM. Abstract content, concept like reasoning, creativity is, of course, really hard to evaluate, reason, understand, have a standard benchmark. Reproducibility, where it's because of the non-deterministic nature, like it's not really hard, easy to replicate the same thing sometime. And because your data is evolving, you would want to make sure that your evaluation platform and your data set, everything is evolving to make sure there is a data drift and everything on that side. So, okay, I'm almost at time. Okay, great. I did it in 15 minutes.
Good job.
All right, thank you very much.
And you should be able
There we
to
go.
share.
All right. Here we go.
Perfect.
So, hey everybody. I'm going to be talking today about building effective agents with small LLMs. Oh, I did full screen without actually doing the slideshow. There we go. Okay. So the agenda for today, we're going to be talking about when you're building agents, what's the difference between building something with a very large LLM versus a small LLM? And then when you do build something with a small LLM, patterns for doing that. And then we're going to do a live demo of a locally running RAG agent that I built as a demonstration of types of patterns you can use for small LLMs. So, when AI agents came on the scene, what was it, maybe a year and a half ago, just as everyone kind of caught on to the generative AI trend and new technology using really large models like ChatGPT, when people started building AI agents, they were also using very large models like GPT-4. And it worked great because you can kind of take these prompts and ask the LLM to do something for you, and you chain a couple of them together, it works pretty well. What happens is, people started trying to use small LLMs, and they would plug small LLMs in and try to get it to behave the same way large LLMs work. And spoiler alert, doesn't work very well. So there are some methods that are kind of can work with large LLMs that don't work well with small LLMs, such as kind of throwing vague prompts and instructions at the LLM, giving lots of responsibility to a single agent, and then when you're taking multiple turns with the agent, kind of passing around full context and chat history. These are areas where when I plugged a small LLM into an agent, that's where it went wrong. So I'm here to show you another way. So just a quick primer, why would we want to use a small LLM? Well, what is a small LLM? I'm defining it here as something roughly 10 billion parameters or less, something that's going to be inexpensive to run. It's going to be inexpensive to fine tune if you want to do that. And you can run it on a personal device if you want to, especially if it's quantized. And the demo I'll show you will be running on my laptop. So some principles for running agents, multi-agent systems with small LLMs is that, you're going to want to treat it kind of like you would treat a team of humans. And just as you wouldn't hire one person for your company and have them do everything, unless maybe you're a startup, but as you scale and want to do things, you're going to pull together teams of specialists and have them work together. So you're going to want to have specialized agents, give them very specific tasks, and you're going to want to give them information on a need-to-know basis. So, for example, if you have a web designer on your team, you're probably not going to give them the entire year executive plan and tell them to figure it out, right? You're going to give them information that's relevant to what they need to get done and some contextual information to understand where they fit in the picture. Then you're going to want people to review each other's work. And when there is communication happening between teams, just as on your development team, it's not a free-for-all, right? It is a structured format where, going in between the teams. You're going to want adaptable planning for your small LLMs and executive decision-making. So as you have a team of specialized agents, You're going to need someone in the director's chair to kind of make decisions. So if you have a plan, you're going to have to know when to pivot the plan, and it's going to take feedback from all of the individual agents and decide kind of where to steer the ship. So again, just think of agents, small agent teams in the same way you would think about human teams and development teams if you're a developer. And I'll put this in a little more context. So the demo that I'm going to show you, where you'll get a little better feel for this, I'm I'm from IBM, and I'm using IBM Granite model. So this is an 8 billion parameter model. It is Apache 2.0 license. I can run it on a single GPU. If I would like it to be super fast, I can run it quantized on my laptop, which is extremely convenient. I do have a beefy laptop. It is the training data sources are fully disclosed. You can go on Hugging Face, read the white paper. It has reasoning capabilities. So this was kind of a perfect LLM to power my agent because it's got the reasoning. It can run locally. And so that's what I'm going to be using the demo with. And this is the demo that I've built. It's on GitHub. I have a link below. But the idea was I wanted to build something for my team to use where we could do search through our team personal documents on our laptop without going out to the internet and feeding our personal documents into something on the internet. We can run it locally. So I to make it easy to use, and I'll show you later, we've got it running inside of Open Web UI and using Olama locally for inferencing locally. It's written in Python, obviously. We're using web search tools and a vector DB locally for database. And what let me back up. So what this agent is going to do is I'm going to pose it a question where it needs to search through my documents and search through the web to find me an answer. So it's going to be using tools to do this. And this is what my workflow is going to look like. So again, rather than taking one agent and throwing a big prompt at it, we're going to break this process down into multiple steps. So for instance, I may ask it, hey, look at my meeting minutes and tell me what things need to get done, and then maybe find me some tools on the internet that can help me, right? So the first step in the plan is our high-level planner will put a plan together, and it'll be something I found that just getting a plan ahead of time, even if you don't stick to the plan, is helpful. Kind of like humans, you need a direction to go in, right? And then you can adapt later. So we get a high-level plan, and then our research agent is going to take the first step in the plan. So that might be search through my documents. So it'll use tool calls to do that. It'll use a tool call to search through the vector database. Our step critic will determine, was that step successful? So if it was search through my documents and find meeting minutes, and it searched through the documents, but they don't look like meeting minutes, the step critic can say that was a failure in a step, and that can be feedback to the next step. Or it could say, yes, it found the meeting minutes. So the next step would be the goal critic, and that will say, did we meet our goal yet? So it'll look at the objective and figure that out. And again, each step in this process, we may not necessarily be passing the full context, but for the step critic, maybe we'll just understand what the last step was. It doesn't have to look at everything. The goal critic, it may look at all the output of all the successful steps and then say, did we meet our goal yet? And then based upon that, our reflection agent will figure out, okay, this was the plan. This step was successful or not, that our goal has been met or not, and then just figure, do we end it? Do we move on to the next step? Do we follow the plan? Do we veer from the plan? So as you can see, these are kind of these micro agents in a way that are taking on these very specific parts, and they're all kind of teaming together. So live demo time. So I've got this running in my web browser. So this is Open Web UI. I'm going to give it a prompt. So I've got some local documents in here that are completely fabricated meeting minutes. And I'm going to say for each open action item identified in my project's meeting minutes, find me some open source projects that can help me accomplish the task. So this is going to get that going. And so it's creating a plan. I'm going to show you the terminal over here. So this shows you all the chatter going in between the agents, and you can see the data that's being passed back and forth. So a little bit cold start on loading the model. All right, so it's got a plan. So here's the plan. It's going to search through the documents to identify the open action items. For each one, so you can see I won't go through all of them, right? So it's got a multi-step plan. So first step, it figures out, all right, if I'm searching through the documents, I've got to use the personal knowledge search tool. So it searches through, it finds the meeting minutes, and here's the action items. And so now we're going to move on to the step critic. We're going to say, was the step successful? The answer is, yeah, successful. And we're going to ask the goal judge, did we meet our goal yet? And the answer is not yet. So we keep going. So then the reflection assistant gives us our next step. For each identified action item, formulate a clear and concise description of the task it represents. So it's going on. Yes, next step, haven't met the goal yet. And now it's doing a web search. So for each of those action items, it's searching for resources on the internet to help us with them. And here it goes. And it's running. All right, step critic. I'm watching the clock to make sure we don't run over. All right, step critic, we did it. Goal judge, did we meet it yet? Yes, we met our goal. And now finally that we've met our goal, the report generator will take all that data that was gathered and answer my question. While that runs, it might take a second. I'm going to show you again the GitHub links in case you're interested. Oh, and here it is. So one of the action items, yeah. So it picked out each of the action items and did a Google search, and dare I click on them? Yes, it's not hallucinated. So there you go. Let me bring up that's the last slide. It has links to tutorials and GitHub repos. If you'd like to just use it for your own usage or use it as just kind of a starting point or a reference point of brainstorming of how to build your own agents. So thank you very much.
Kelly, I have one or two questions for you, just to bring it home. I think this was really impressive. Thank you so much. Doing it live also pretty impressive. Just to throw it up. So you used the 8 billion parameter model here that you used, I think 4 times, if I counted right. 4 agents, 4 times, so on, right? Maybe loops, but let's
In a
just
loop, yep.
pass. And would you argue that if we were to measure some kind of accuracy, I mean, let's not dive into the details, but some kind of
Yeah.
performance accuracy, would you argue that this would be same accuracy as maybe I'm gonna throw a number there, a 70B model that you would only do once, that you would run once?
That's a good question.
Or 250B?
Is it the same accuracy? I mean, I think in the end, you care about the end results, right?
Yeah.
And I think the end result is, yes, you can get the same results. Depending on how, I think the emphasis here is the important thing here is how you design your workflow, right? And I think you can achieve the same results with a very larger model with smaller models if you're designing your workflow properly.
Yeah,
Yeah.
and this is the point I was trying to make, because this can run on your laptop, could run on a phone, could run in a what's called air gapped, so you don't have access to cloud GPUs. So I think this is very powerful, right? And that's where I was going with this. I was like, with the
Yeah.
8B, let's say by orchestrating it and a right workflow, you can replicate a 250B model by itself, and it's pretty amazing.
Awesome. Yeah, I think so. Thank
All
you
right,
so much.
super. Yam is the CEO and co-founder of Parlant, an exciting open source framework to create robust, user-ready service agents. Yam, good morning.
Hey guys, am I
Good evening
audible?
for you.
Am I audible?
Yep, I'll let you take it away.
Great. So let me just share my screen.
Good to go.
Let's see, full screen. Can you see it?
Yep.
Okay, see my presentation, yeah? Okay. It's nice to meet everybody. My name is Jan. I'm the CEO of MC and also happen to be one of the tech leads of Parlant, which hopefully some of you have heard about by now. Now, in this talk, basically what I'll be sharing is some insight that we picked up from working with and advising some of the largest companies in the world. So stick around if you want to hear what I would say is like the truth about building conversational AI, at least at the enterprise level. Now, the first thing I want to say is that if there's one thing that we always see is that everybody's boss thinks that building conversational AI is going to be easy. You may have seen that for yourself. So the reason this happens is because we're all flooded with marketing messages telling us that if we pay some company, some vendor, some amount of money, then we'll be able to deploy real good conversational agents today. But in reality, what we're seeing is that everybody's still basically trying to figure out how to deliver a real next-gen agent. Well, I would say doing a half-decent job at it at best. And in my opinion, that's just the truth based on what we're seeing in practice. So what I want to talk about today is why is this so hard? So the first thing that's really crucial to understand is that if you're operating at the enterprise level and you're building an agent that communicates with your customers, you really can't afford any lack of precision whatsoever. Now, the problem with LLMs is that it's not just about how often they get it wrong, but the more serious problem is that you don't know just how wrong they're going to get it. So, for example, if you have a banking agent, it could easily tell a client that the transaction was processed when it wasn't, or alternatively, like that it wasn't processed when it actually was. And this is really super common stuff that you have to deal with when building these agents, and there really aren't any trivial solutions. At least not ones that don't completely degrade the user experience to where you're not actually getting an LLM experience anymore. So to touch on a few of the technical reasons why this is so hard, we need to understand that an LLM is not a logical thinking machine, but basically a very sophisticated pattern matcher. So when it generates outputs, it generates them token by token, or you can think about it as word by word to simplify. And every time it generates a token, it has to choose the right one between roughly 200,000 different ones. So 200,000 is actually the vocabulary size of GPT-4. And what you slowly come to realize as you're building is that you're just not going to get it to generate the right next token every single time. And this becomes an even bigger issue when you provide it with a lot of custom instructions at the same time, as it essentially, what it does is it evens out the probability distribution of the next token, which you can think of as lowering the focus or basically inducing ADHD-like symptoms on the model. And I mean, I guess we can sympathize with it in those cases. So what you have to do is you have to find ways to manage its attention span. So basically to keep its so-called cognitive load low enough for the task at hand. Now, an important thing to keep in mind here is that the task at hand is not necessarily, let's say, completing a transaction, but it's really to take the right action at this point in a conversation and generate the correct new message in it as well. So it's a smaller problem to solve, but it's still very difficult. Now, because we talk regularly, I know our company, we talk regularly with a lot of engineers in the field, some of which are, trying to basically contributing to Parlant. Some of them are using it, some of them are considering. We've built up by now a pretty good picture of what's going on in the market today and where the challenges are. And to be fully honest, and we've been through a lot of these same rabbit holes ourselves too in the beginning. So there are four main approaches that people take in different places. Let me cover them briefly because chances are you're probably working on the same approach where you are, or one of them. So the first one is using a system prompt. So basically capturing all of your instructions in a system prompt and then letting the LLM API, like for example, OpenAI's, to generate the next message every time based on that initial system prompt. Now, the problem with this is that if you've seen it yourself by now, it's really, really poor at capturing your semantics and rules. So the resulting accuracy is basically always horrible. And I would say it's just super unfit for scale, you know, if you care even just a little bit about your accuracy. Now, where we usually see this happening a lot is in companies that are trying to build real-time voice-to-voice agents, which, at least in my opinion, I think if that's what you're trying to do today, I really think you need to reconsider what you're working on right now and what you want to deploy in the next year, because that, I mean, this is just my opinion. I don't think anybody's going to be releasing high-quality voice-to-voice agents at an enterprise scale in the next 3 years. Now, I'm happy to talk, you know, and explain why that is in person in more depth, but that's kind of beyond the scope here. Now, the next approach that is very common is using a Q&A bot, like deploying a Q&A bot to your customers using RAG, retrieval augmented generation. This actually is, you can make this work pretty well by now. So if that's what you're working on, that's great. And the only thing is that it's a very limited approach, so it can't really do customer service, and it's also very passive. So it depends on your users to tell your agent exactly what they want and what they want to know about, etc. Which is, once again, is not what you really want with customer service, which needs to be more proactive and handhold and help the users fix their problem with its own knowledge. So the next common approach is fine-tuning. And the problem with fine-tuning, and again, I'm happy to expand on this more in person if you're interested, but basically you're going to get limited results depending on how you're using it and what you're using it for. But if you're using it for the conversational setting, then basically you're going to get limited results. It's going to be expensive and it's going to take a lot of effort. And perhaps the most common approach is so modeling your conversation as part of a graph or a flow chart. Now, this is, like I said, very common, but what not many people talk about enough is that it actually imposes too much structure in a conversation, and that hurts you in a few different ways, which leads me to my next point, which is what we call the myth of the happy path. So one thing that we've learned by working with one of the the larger banks in the world is that real customers don't want to and don't tend to follow neat step-by-step patterns in the conversation. So what happens if you try to force them down those paths, basically like older bots have been doing for the past 8 years, then long story short, you're just going to lose them. And so the thing is, you probably lose them very fast. And even worse, you're not going to get them to try your agent again for another year because they'll remember, oh, I tried that and it sucked. Now, I actually recently heard a conversation design specialist label this phenomenon as what he calls emotional debt, which I thought was a good way to understand this. So basically, if you care about what's called containment, so containment is essentially the ratio of how many conversations are handled by the AI instead of being routed to a human representative, then I would really suggest for you at this point to avoid modeling your agent on what's basically a legacy usage pattern at this point. Now here I want to give you a personal example of something that does work well. So I recently, just a few days ago, actually, I had a billing problem with some of my service provider that I use. And I was quite frustrated at some unintended charge that I got. So I opened up their customer support page and was immediately directed to a bot. Now, since the issue was right on my mind, I basically described the whole thing in one message, as you would. So like the whole issue and what I wanted them to help me with. But at the same time, I was skeptical. So before I sent that message, I copied it, basically thinking that the bot will probably force me through an annoying series of steps before it transferred me to a human rep. So at least I'd have my real issue ready to be pasted into the human chat. However, so to my surprise, the AI immediately responded with nuance. So it didn't force me through any steps. It just recognized and validated my issue. Now, because it wasn't an advanced agent, it did in fact quickly transfer me to a human agent, but still that initial experience of not having to get funneled down a stencil was what kept me in the chat box throughout the conversation until I resolved the matter. Now, if the AI could actually solve my issue end to end, that, I would have been super happy about that. But basically what I'm saying is that's exactly the kind of user experience that we should be looking to build today. So now the question is, how do we build it? Because it's difficult, what we have to do is to strategize and not go for the first thing that may come to our mind or that we may read about somewhere, which, trust me, I know firsthand is sometimes the hardest thing to do. But I personally would really like to implore you not to do that if you really want to deliver cool stuff soon. So we basically need to prioritize and understand what's really important when building our agent. And the first thing is that, as the tech lead from the bank we're working with said, that he would take a 1% increase in precision, even if it means 10% less recall or even more. What that means is, especially if you're operating at scale, is you prefer not to say anything, and if needed, you transfer them to a human agent, than to actively mislead your customers. That's much more harmful. It's much more damaging. So this is why I think it's better to build one thing after another, like one use case after another, support it in your bot in a reliable manner, than to try to release a whole bunch of features with 99% accuracy, which, like I said before, essentially means thousands, if not hundreds of thousands of unbounded problems per month that you're going to have to deal with. Now, to build something reliable is actually easier than you might think, especially at an enterprise setting where most customer conversations are actually quite repetitive in nature. Now, by that, I don't mean that every conversation flows down the same conversational path, not at all, actually, but that the problems people are trying to solve repeat themselves. And you can use this to your advantage, because what it means that, so A, there are only so many things that your agent needs to be able to address and respond to. And the important thing is that it responds directly and fluidly rather than forcing the flow of the conversation, basically making the customer feel unheard. So they may have specified, what their issue was, and then the agent just was like, sorry about that. And then it keeps asking a bunch of questions that it already got the answer to, right? And the second thing that you can leverage is that your business experts probably already know what those common use cases are, and they can work with you to model them in what can potentially be a matter of weeks, and that can actually be realistic. However, what it also means is that you need a system that allows you to do this kind of iteration with your business experts in an efficient manner. So you can basically incorporate their feedback quickly, easily, and reliably on an ongoing basis. So it sounds crazy because so many teams today are spending months or sometimes even years trying to get to 90% accuracy or higher when it's really not anywhere near good enough anyway. Where in practice, with a little bit of teamwork and setting the right priorities carefully and having the right system to implement them, you can actually get to a next-gen agent in just a few months.
Yeah, time check. You have 2 minutes left.
2 minutes, that's great. So an agent that your customers are actually going to love, just as I personally like my recent experience, despite the fact that it was quite limited. So that actually brings me, of course, to Parlant, which is the open source system that we've created to allow you to incorporate that business feedback smoothly into your agents and to do some data-driven iteration to improve it with a better version every 3 weeks. So yeah, having said all of that, I would like to invite you to check out our website. And of course, if you're looking for feedback or advice, then feel free to reach out to us and we'll be happy to chat. Thank you.
We have Shelby. Shelby is a senior AI researcher at Salesforce. Her team has published 15 plus AI research papers, filed 10 plus AI patents, and released several competitive open source LLMs. Shelby, take it away. I will stop sharing.
Let me just get it up going.
And you're good.
Okay, awesome. Let me put it. Okay, good.
All good.
Perfect. Thank you all so much. Yeah, really excited to be here. So, thank you for that intro. And you mentioned that we released several open source competitive models. That's exactly what I'm going to talk about today. So, we recently just released what we call large action models. Now, we released our version 2 of these models only a couple weeks ago. So this is really new information and it's extremely competitive. And I'm really excited to tell you about what these large action models are, right? Because LLMs are pretty awesome. So how are large action models a little bit different? And I'm going to show you how we've built them and how they're beating industry leading models. So let's get started. A little bit about myself. Again, you heard from the introduction. I lead an AI research team at Salesforce. We're focused on developing the next AI that our customers and our products are going to need. And key focus areas for my team are AI agents, which is today's topic, but also related topics. Small language models is something I focus on device AI, on device agents. These are things that we think about. And we publish our research all the time and we open source a lot. Of course, a lot of things are going into product, but we're publishing, we're open sourcing even data. So everything I'm going to talk about today, completely open source, everyone. So I'm going to even give you links. You can check it out. You can try it out yourself. And of course, I'd love to connect with you all on any of this outside of this talk. Feel free to scan the QR code to connect. Awesome. So let's just get right into it. What are large action models? How do they work? So let's start with what we all know. We all know LLMs, right? You take a prompt, hey LLM, write me an email. You give it to the LLM writes a great email. We know LLMs very well at this point. But what's essential for agents is not just generating any text, it's generating actions, right? So if we look at this prompt here, it's different. This prompt is saying, what meetings are on my calendar this afternoon? Now, if we give it to an LLM, a typical LLM, without access to tools or anything, is not going to be able to answer this. To know what's on your calendar this afternoon, we'd have to access your calendar, right? LLMs, because LLMs are trained on historical data, they're not going to know exactly what's going on at every point of the day. And as you can imagine, there's a lot of prompts like this where a plain LLM would not be able to answer. However, if we empower that LLM with the ability to take action, allow the LLM to be able to navigate a calendar, to be able to navigate apps, to call databases, then we can do this. And that is the key for AI agents, right? So again, the key here is that we need to empower this LLM to take action. So what do we mean by taking action? An LLM still is generating text. So we're still talking about an LLM here, but how can it empower action? Well, it can generate completely executable text. So let me be specific there. So imagine that the LLM can generate formatted text that one specifies the tool or app that's needed. So it's very clear about that. So given that prompt, it selects the right tool or app. Two, not only selecting the tool or app, right? It needs to select the functions, the actions to take in that app to execute the prompt. So if we go back to our running example here, we have, again, what are our meetings on my calendar this afternoon? We want to select the right app, which is the calendar app here. And we want to also select the right actions to take within that app. In a calendar app, there's a lot we can be doing, right? We could send events, we can cancel events, we can schedule things. Given this prompt, we want to select the right function to do in that app. This is a hard problem, everyone. This is pretty challenging because what we're asking an LLM to do is, given this prompt, select from all the possible apps, all the possible tools. There could be hundreds, thousands to choose from. So this LLM has to be really smart to do that. And we're also asking it to pick the right functions to do. So this requires a lot of intelligence to do this. So this is exactly what a large action model is, everyone. So it's an LLM that is optimized for taking action. So again, still generating text under the hood, but as you can see here on the right, it's generating a completely executable action. So this should be completely executable. It could be an API call, it could be a function call. So as you can see here, the correct app is specified, the function to take within that app is specified, as well as the variables needed to actually execute that function are completely specified, all based on the prompt. Now, again, our large action models are optimized for doing this. And another important feature about our large action models are their size. Okay, this is super important. As we think about more and more complex agentic tasks, there's going to be multiple steps, right? So the smaller the model, the faster each execution of that step is going to be. So if you can imagine here, if we look at this prompt, organize a team offsite for Q3. So much going on there, right? There's probably tons of steps that will be needed to actually to organize and execute that. So we could call the large action model to get each step right in the process and take the right actions. But if that large action model is also small, it's going to do each of those steps super fast. So we've got speed and we've got accuracy with our large action models. So I want to introduce to you all our open source family of large action models that we call XLAM. I'm going to give you the link at the end so you can check it out. It's all in Hugging Face. But these models, we've just released the second version only a couple weeks ago. So this is very new. We've released 5 models ranging from 1 billion parameters all the way up to 70 billion parameters. So that 1 billion parameter, if if you look at other model sizes, I think I have a slide here showing this. That's 1 billion parameters is really, really small. So it's going to be super, super fast. And it's really competitive. So I'll show you that too. And so this new version that we just released a couple weeks ago is really good at handling multi-step tasks. That's the future of agents, right? It's not just performing simple tasks, it's multi-step. We've got that covered here. And most importantly, this is all great, right? We've got small models, we can handle complex things, but is it performing well, right? It's number one, everyone. Our models are number one on function calling leaderboards, beating industry leaders ranging from GPT-4o, Claude, and so on. So I'm going to get all into that. So again, one of the important features about our entire family that we release are the range of sizes. Now, these different range of sizes allow for diverse applications, right? The 1B model is going to be great. It's going to actually be able to fit on your phone. It's going to fit on regular phones. Now, the small models could be good for, performing this on your laptop. Maybe you just want a local model, tablets, and other devices. Then you've got the medium and large models. So let's take a look at the smallest family members. Yeah, and as I mentioned before, these are super tiny. So just to give you guys a comparison, if you look at this, we look at some of these well-known LLMs today. Look at how many parameters there are. DeepSeek, V3, 671 billion parameters. Mistral Large, GPT-3, Llama. These are big models. They're amazing models, right? Amazing models, but they're a lot of parameters. Our models, we've got a 1B, a 3B, right? And a 8B model. So super small in comparison, which means less resource consumption. It's going to be super fast. Yeah, so as I mentioning, so many benefits to these small models. Good performance, I'm going to show you that on our leaderboard. Fast, cost efficient, sustainable, of course, trusted, and we can deploy it anywhere. That's really the key. So if we imagine being able to take one of these smaller models, maybe that 1B model, and putting it on a phone, here's how it could work. So you could take that. So you imagine you have the prompt about scheduling on your phone. That prompt will be passed to the 1B model, and the 1B model would select the correct tool, would write the right function call. Then the back end of your app or your phone would be able to execute that action. So actually making that API call. And then XLAM would generate the final response, as you can see here, which is you have a meeting tomorrow at 3 p.m. So this is an example of how you could leverage XLAM in a workflow on your phone. But of course, similar things, on any of your devices or on cloud. This is how you could leverage XLAM. Now, as I've mentioned, we also have the medium and large members, but let's get right to showing where they all stand on this leaderboard. So if you check the Berkeley function calling leaderboard, so this is one of the most important leaderboards out there. It ranks models on simple agentic tasks or simple function calling tasks all the way to multi-turn, multi-step tasks. And so what you can see here is that our models, our 70B model, our 32B model, are number 1 and 2 on the Berkeley function calling leaderboard. If you check that leaderboard, you can see in this screen clip, beating GPT-4o, beating plenty of other industry models. And most impressively, if we look at our 8B model, so only 8 billion parameters, that's a really small model, beating GPT-4o on these tasks. Now, where did our other small models place? They still place pretty impressively for their size. So again, a 3B model, only 3 billion parameters, is still ranking quite up there, beating a lot of industry leaders on these tasks. And finally, our 1B model. Again, still pretty competitive for being only 1 billion parameters, one of the smallest models on this leaderboard. So so how did we achieve this? So the key, everyone, is all comes down to the data. That's really the key here. As I mentioned, these large action models are still LLMs under the hood. So what we did is we took base LLMs. We had some pre-trained model. We started with some open source pre-trained models. That's nothing super special, right? What was special is we generated very carefully what we call action data or trajectory data. So if you look here on the right, this is an illustration of what one data point of an action trajectory looks like. So what we did, if we look here on the right, we see a task. So here, for example, the task is, what is the phone number and email of my friend Astro? And what we see below are the correct actions to take to complete that task. So the correct actions here would be to navigate contacts and get the phone number of Astro. So this would be the actual API call. The second step to take would be to actually navigate contacts again and get the email of Astro. So this is just one single data point. We generated thousands of data points like this. And so imagine if you have thousands of data points like this, you train your model on that, your model is going to be really good at generating actions and executing complex tasks. That's exactly what we did. So as I mentioned, I'll have a link in the next slide. We have released a lot of ideas on how we did this. As you can imagine, looking at that trajectory data, you can't just find that anywhere, right? That's not common. Going back to that trajectory data, this is not common everyday data, right? If we look for data, there's plenty of open source data sets that we've seen in the past, but this is a newer emerging type of data and so we've released multiple publications on how we've synthetically generated this. So I encourage you to check this out to get some ideas there to understand how we did it. We've also, as I mentioned, open sourced the model and also part of the data. So with that, hopefully that gave you a little preview of XLAM. Check out XLAM on Hugging Face. You can check out even some of the data. The papers will be linked there as well, so you can see how we generated that data. And we also started a new YouTube series that I'd love for you to check out too. Thank you all so much.
Shelby, one or two questions. So
Yeah.
is this in production to power some of the AI agents at Salesforce?
No, it is not in production yet. Right now, it's at the research phase. But yeah, we hope that in the future it could be deployed.
Okay, that's the idea. Where do you think this is going after? This is obviously very impressive. I love the domain specific of it, and it just builds upon the whole specific AI agent and powered by domain specific models. Like, where do you think this is going next?
Yeah, I think you know, continuing to broaden the data set, that's one of the challenges. I think data is the challenge for getting AI to, perform in different domains. So, thinking about increasingly complex trajectories, how do we generate those? How do we make sure they're correct? That's generating new processes for that. I think that's going to be important. Um, and again, doubling down even on model size and model efficiency. I think what we're seeing today is latency, is becoming more and more important for agents. I think in the past year, we've been focusing on just getting an agent to work, right? But now the industry, we're starting to get agents to work. Now we need to speed them up. And so I think doubling down on these large action models or whatever you're using for your agent, thinking about small models powering as many steps as you can to improve latency is going to be key too.
Shimon, I'll let you take it away. Tell us how we're gonna do this. Create robust AI agents.
Awesome. Thank you, JP. Yeah, very nice to be here. And thanks everybody for attending this awesome conference. So let me share my screen, and I want to actually talk about Model Context Protocol, which everybody's been kind of like talking about the last few months. But I want to share a couple of like really foundational things that I think it enables that we currently don't have in our Discord moment. So I'm going to just share my screen real quick. Let me know if with a thumbs up if you can see my screen, JP. Awesome. Cool. So I think just taking a step back and just thinking about the use cases for AI agents, especially ever since kind of ChatGPT came out, there's been this dream of connecting LLMs to unstructured data sources, to APIs and tools within an organization in order to perform actions and tasks. And we kind of talked about large action models just before. And so like really for AI to be operable, it needs to connect to the world around it. But unfortunately, as everybody's kind of been seeing so far, a lot of these high impact use cases have been kind of stuck in POC purgatory for a while. And these use cases may be things like workflow automation, information retrieval, data processing of unstructured data, and so forth. But I think things are actually changing really drastically this year that make a lot of these use cases possible for robust kind of like agent application development. And I want to cover especially MCP, but also just generally like some of the trends we're seeing. So the first thing is the models themselves are getting way better. And so we have reasoning models now, which kind of do a lot of the complex work at inference time with test time compute that used to happen at the framework layer. So for example, there's React and chain of thought reasoning and tree of thought and like all these other kind of algorithms that people developed to help LLMs reason better. A lot of that stuff is now actually happening at the inference time for reasoning models today. And so you can kind of simplify a lot of this complexity that used to exist when you were building an application by just trusting the models more. And then the second thing that's happened that's really important is actually this standardization that's happened from Model Context Protocol. And that standardization is basically a way of giving a standard API for LLMs to connect to tools, to data, to external systems without having to like re-implement it as you onboard new APIs and new services for your application. And the last thing is actually trust and safety. We'll cover that towards the end if there's time left, but there are also better techniques for AI evaluation. And you can check out our company's website to kind of see how we can leverage small language models and fine tune them to understand a particular application or agent and learn a metric, an evaluation metric for that specific application. So the thing that I really want to double click on today is this project that we have open sourced called MCP Agent, which is a very simple library that allows you to build AI agents using MCP servers. And so it's basically the bet we're taking is that the whole world is going to be MCP native pretty soon. Different services are going to expose themselves as MCP servers, and different line of business applications are going to become MCP native clients. And that's already happening with, there's a GitHub MCP servers to interact with GitHub. And then there's also MCP clients like Claude and Cursor and VS Code that allow you to use those servers to build, to basically do agentic workflows. So the key observations we have are that MCP is basically going to be everywhere. Even I think at Microsoft Build this week, they announced that even Windows is going to have an MCP native like layer at the operating system, which is pretty cool. But then there's like a couple of things that I don't think we've really scratched the surface of yet, which I think are even more transformative than what people are giving MCP credit for. The first one is actually MCP agents can be exposed as servers themselves to allow multi-agent interaction across the same MCP protocol. And I'll show a demo of this in a bit as well. And then the third thing is workflows and workflow patterns for how you build effective agents should be pretty composable. And there's a very popular blog post from Anthropic called Building Effective Agents that came out at the beginning of this year. And so what MCP Agent does is it combines all of those patterns that were defined in that blog post and gives an implementation of them in a way that you can actually build more sophisticated workflows from the same building blocks. And the building blocks are pretty simple. Like in the simplest case, it's an augmented LLM, where an LLM is connected to tools, to data like memory or resources, and all of that interaction is done via the MCP protocol. And then the LLM just runs in a loop. It's given a task. It calls the tools, it retrieves the data, it does its thing until it accomplishes the objective. So this is like the simplest kind of agent you can think about. Then you have like more complex workflows that build on top of this. So in this case, there's an evaluator optimizer where you have two LLMs that are interacting with each other. One of them is calling like the generate function to generate a response. And the second one is an evaluator, which is basically evaluating the quality of that response and giving feedback to the generator LLM. And this runs in a loop until basically the evaluator is happy with the response that the generator produced, and then you return the result to the user. And again, the generator and the evaluator could be a more complex workflow. Like each of them could be making tool calls, could be connecting to different data sources, etc. So it's not just a single LLM call. It's basically like an agent that you integrate in here. Then there's like another pattern called parallel workflow, which is for people familiar with distributed systems. It's just like a fan out of an input going to multiple agents in parallel. And then once all of those agents complete their objective, then an aggregator basically fans in all of their agent responses and synthesizes them into a single output to return. So from the user's perspective, it may still be like an input to an output, but under the covers, it's actually like invoking multiple agents, awaiting their responses, and then synthesizing them back as a single response at the end. And I'll actually give an example of perhaps the most complex of those patterns, which is this orchestrator worker. And in this case, you may give a very complex, like open-ended task. And then you give one LLM, which is the orchestrator or the planner, the task of figuring out what the order of operations is, what the plan should be to execute the different agents with. Similar to this workflow, except in this case, a programmer or a developer like decided which agents to invoke. But in this case, you're letting an LLM kind of on the fly dynamically determine what are the right agent invocations to have. And then at the end, it like synthesizes all of that and returns a response to the user. Don't take a look too much at the code here. I'll actually show this when I do a demo in a sec. So one of the things that you already see from a lot of this is agents are complicated, right? They're like long-running tasks. They may be paused, resumed, retried. There may be a human in the loop in some of those cases. They may be making multiple tool calls, connecting to multiple MCP servers. And so really the right way to think about them are agents are actually like async workflows. And so basically the same principles that applied in distributed systems for workflow orchestration apply to AI agents. And you're starting to see that with a lot of the products that are coming out today. Like there is, there's deep research, there's Operator from OpenAI. There are a couple of these things that basically take like tens of minutes to do their job. And they're basically executing somewhere in the back end asynchronously. And the second thing that I really want to point out is today, if you think of like how MCP is integrated, the client side is basically the agent, right? So you have a Claude desktop app, it connects to MCP servers, and then you give it a task, and the Claude desktop app is then figuring out how to invoke those servers and do some like accomplish your task. So basically, the MCP client is the agent in that case. We actually want to flip that paradigm. We, an MCP agent, allow you to create agent applications and expose them as MCP servers themselves. And what that allows you to do is it allows you to basically have multi-agent collaboration across the same base MCP protocol. And it also allows you to build your own agents and use them in any MCP client. So for example, I'll actually just demo this right now, but you can basically create an agent workflow. You can then expose that as an MCP server, and then you can use that in Claude and Cursor and any MCP compatible client. And even more importantly, you can actually run those workflows that I just showed you in like dedicated infrastructure, not just running client side, but even in your own hosted environment if you're deploying these to production. So let me actually put all of this together to show you what all of this actually looks like. So one of the things I want to show you is the workflow aspect of it. Here we use temporal for orchestrating all of these things. So you'll actually see there's all these workflow steps that happen to accomplish a task. In this case, I have this workflow called the orchestrator workflow, and it's a fairly simple task. It basically it's supposed to help us grade a student's short story. So sounds simple, but then the task is load the student short story from this markdown file, and then generate a report for proofreading, logical consistency, style adherence. For style, use the style guide from this URL, and then finally write the graded report to this markdown file. So it's a lot of steps, and the orchestrator basically is given access to these individual agents. Each of these agents can connect to different MCP servers, and then the orchestrator has a planner which basically figures out how to use these agents to accomplish the task that was given. Now, the cool thing is this whole workflow is like exposed as this MCP agent workflow application, and I can run this from anywhere using MCP agent. And so in this case, I can like run it from the CLI. And what you'll see happen here is the execution here is going to happen in a workflow orchestration backend. In this case, it's temporal. And the first thing it will do is it will figure out what's the plan that it should generate, and like what should the application actually do, and how should it orchestrate all of it. And then it takes a minute or two, and like it basically calls the right agents. It's calling different MCP servers. It's doing everything necessary to complete the task. But like tasks may fail, they may be retried, this workflow may pause for a human in the loop. And so all of this is like happening asynchronously behind the scenes. But the cool thing is this agent can actually be exposed as an MCP server here. And so this is MCP Inspector for folks who have built MCP servers. You can kind of like use it to see the different tools available. So you can actually see that the workflows are available as MCP tools themselves. And then I have this whole workflow, this agent workflow connected to my Claude desktop. And I can ask it to grade the student's short story exactly the same way that I ran it from the CLI. And so the really cool thing is the agent application that I built is then exposed through an MCP native client here. So if I just try to do this, so let's say use the agent server to grade the short story, and let's run this again. The Claude desktop will figure out that there is different workflows that the MCP server for my agent exposes. It then generates the right like set of tool calls to call in order to execute that workflow. And then once it's done, it basically like polls for the status of that workflow because it's happening asynchronously. And then finally, like it generates the response that the workflow produced right in here. And so you can now think about this as basically this way of doing multi-agent collaboration all through an MCP native client, and also writing your own little like apps that are agent applications built with MCP agent, but expose them as MCP servers so that you can use them with any MCP compatible client. The next thing that we're working on from here very, very quickly as a demo is actually like, how do you deploy MCP agents and how do you deploy MCP servers is something that requires really deep thought about evaluation, about authorization, about authentication. And so we're trying to solve all of that by this platform we're calling MCP Agent Cloud. And so you can deploy this within your own enterprise VPC, or you can actually like just have like a CLI called MCP Agent Deploy and get an HTTP endpoint for your agents that you can then use in any kind of like MCP client, similar to how you integrate any MCP server. So I'll pause there, and I'd love to take a few questions at some point as well.
We have 2 minutes per question. There's like 41 questions, so I don't know if I'll have time to go. They're not all related to this. Maybe a tricky question for you. So Google has agent to agent.
Yep.
You're doing MCP, I would say to an agentic network, not specifically to an agent. Is that correct?
That's exactly right. And we've actually thought about exactly that question about like, how does this relate to A2A and these other like protocols coming out? Our fundamental premise is that the world for sure is going to be MCP native because everybody's adopted that protocol. And there's a lot of patterns that A2A has around agent authorization, around like how agent tasks should be handed off between agents that we can implement with MCP as well. And then you can like still expose them as A2A servers where necessary. But at least what we're seeing is there are many MCP clients out there already, but there aren't as many A2A clients yet. So it's probably just early in that adoption curve. But our fundamental premise is like aligned with A2A, that agents should be exposed over some shared protocol so that you can kind of like interact with them in a seamless way from any application that you want.
Perfect. Well, thank you so much, Samad. Anita is head of hardware infrastructure transformation at Microsoft. And we're gonna switch it around here. We're gonna do a Q&A session. And And Anita, of course, I have some prepared questions, but if there's questions that you've seen that you want to start to answer first or set up the stage as you see fit.
Hi, Jean-Marc, and hi, everyone. Thank you for having me here. First, as we go through this, what we're going to touch on and what I'll be mentioning is applicable. We wanted to talk about talk on AI agent implementation in the enterprise, and those are the questions that we prepared. But a lot of it is applicable beyond enterprise. It's just that my experience has been that these concepts are more common in enterprise because they are the ones with lower risk tolerance, existing legacy systems, and maybe the appetite and resources to build a robust, custom and scalable AI agent solution. So keep that in mind, right? It's not just enterprise specific, but I think it is the superset of these challenges. And before we get to your questions, Jean-Marc, I will be staying away from specific tools and frameworks for the most part because these change rapidly, right, as we've seen throughout the day. And I believe if you master the fundamentals, then you can easily adapt and choose the right tool to accelerate your own deployment. So if you are a tech business leader planning your AI agent implementation, this will give you the big picture of things to consider. And then if you are an AI engineer or an AI builder, this will help you understand how to scale and make a bigger impact. So let's start with your first question, and I'll also be sharing.
Yeah. So, to set up the stage, you've been deploying, AI and AI agents in production and enterprise environments. What do you think are the primary challenges there that people face once they get to that?
Yeah. Great point. This is based on my own experience. It's not just plug and play. When companies try to roll out AI agents and generative AI solutions in general, they run into a host of challenges that cut across technology, data, people, and governance. So it's definitely not just technology. First off, there's the legacy headache. Most enterprises rely on old school systems. Think ERP, CRMs, clunky databases, or worse, internal tools with old APIs or no APIs that were never built to talk to modern AI. And even when those APIs do exist, or when connectors exist, or when we can use MCP, they often break as soon as something changes upstream. And the pain here is that unlike traditional software, which tends to throw a clear error most of the time, AI agents might keep working. And I say working in quotations here, but they're actually quietly generating wrong or misleading results. And this is especially dangerous in regulated fields like healthcare, finance, legal, where an almost right answer can actually be a disaster. Next, let's talk about the data privacy and compliance. AI agents, as we all know, need massive amounts of information to work. And some of that information is sensitive. If you're not careful, these agents can access or even leak data that was supposed to stay locked up. And a classic example, or I think it's becoming classic, is you have an employee who downloads a confidential database report to their desktop for legitimate reasons, right? That employee had access to the database through an authentication service, and the agent does not have access to the database. But because the agent has access to that employee's desktop, now it bypasses every backend security protocol that you had in place, and that confidential data can end up in public documents or in the wrong hands. And of course, as I said, it doesn't stop at technology. I think organizational culture is a major hurdle, and that does show up more in large enterprises versus if you're, a single freelancer or a small business, because employees tend to be apprehensive or resistant, and I don't think it's because they perceive it as a threat to their jobs, but because they worry that AI agents dramatically change existing workflows. So there's that mistrust there. And I think that's why you need proactive change management, because without buy-in from real users, even the most sophisticated agent, will be left on the shelf. We've talked, I think there've been plenty of mentions how more than 80% of AI solutions never leave the lab. And that's one of the reasons, right? You don't have buy-in from your users. I think you need to show your users how it will make their life easier. And my experience is that the key to adoption is user experience. Don't make your employees switch apps or learn a whole new interface just to use the agent. Meet them in their existing workflows. And of course, there's the other challenge is cost. I'm not going to get into too much detail here, but building AI agents at scale isn't cheap, and the ROI is often uncertain. I think we're still, in many cases in enterprise, we're still learning how to measure the ROI of generative AI solutions and AI agents implementations. So always recommend that companies start with a pilot that's focused on a high impact use case, and then scale from there to additional use cases. And then another core challenge I'd like to touch on is the unpredictable behavior. AI agents, especially those powered by large language models, don't always behave as expected. And that's because models, as you know, are stochastic and sometimes producing different outputs for the same input, or they make reasoning errors. And in an enterprise scenario, this kind of inconsistency is problematic because business processes tend to demand reliability and repeatability. And I highlight this as a challenge because I think it often surprises leadership in enterprises that an AI solution that performed well in a demo can then erratically act in production. I think it's the so-called Jekyll and Hyde problem. This is something that I touch on in my MarTech Post article around agents and how to address that with the comprehensive data source in production. Yeah, those are the challenges in summary, John Mark.
What do you think what are a few solutions or approaches to, ensure these AI agents, and you touched upon it, but I just want to double click on that, are reliable or consistent or predictable, do what
Yeah,
they're supposed to do.
let's talk about that. I think if there's one thing that every business leader I've come across wants from AI solutions is reliability. You can't have an agent give you different answers for the same question, or worse, hallucinate data. And here's where I recommend enterprises go back to fundamentals, specifically a tried and true software engineering framework. I recommend they adopt test-driven development, and this is something that became clear to me just in the last 2 weeks as Alpha Evolve launched. So before letting an AI agent loose in the wild, build robust evaluation frameworks. Think of them as a suite of unit tests for the agent. You want to define what's good for each task, and then run the agent through a battery of scenarios until you're confident that it delivers the right answers consistently. Google DeepMind's Alpha Evolve is a great example because it uses automated evaluators, and it only keeps solutions that pass objective metrics. And I think enterprises should do the same. You want to validate before you deploy these things. And of course, some outputs may not have some objective metrics, but you can still create confidence filters based on human evaluation. The other thing to keep in mind is that reliability isn't just a pre-launch concern. I think monitoring has to be continuous post-deployment. So you want to set up dashboards to track the agent's decisions, error rates, and anomalies. My experience has been that every single AI solution or AI agent project needs tweaking after launch. Continuous monitoring and rapid response to feedback is non-negotiable. And I know monitoring is not sexy, but you can make it so. Take a look at this dashboard here that I built that I think makes monitoring sexy, and it empowers you with so much knowledge. One cause of inconsistency is the inherent stochastic nature of AI models, which I mentioned earlier. And that's a feature that produces different results on different runs. And to counteract this, enterprises can adjust the AI model settings and usage to favor consistency. And of course, there are trade-offs, right? because the more you constrain your model, the less variety of output you have, but you have to think about your use case there. And you can constrain that randomness by setting low randomness, by fixing the model version in production, which means, don't just use any update without running your evaluations first. Just because, OpenAI pushed a new model, it shouldn't automatically go into production in your solution. First, evaluate that update works. And then double check your outputs, especially for mission critical tasks. And then one of the things to keep in mind is that when things do go wrong, make sure that you have a fail-safe option for that agent where if it's unsure, it escalates to a human and doesn't just guess or hope for the best. Yeah, and I think just to sum it up, keep your first agents simple and focused, because if you just build sophisticated but unreliable agents, you're causing more harm than good.
So that's maybe for my last question for this session is, you talked about starting with a simple agent, and there's more and more autonomous agents that are coming out. What are the ways to kind of mitigate the risk associated with this autonomy that's powerful, useful, valuable, but yet risky?
Excellent point. I think autonomy is both the magic and the minefield of agentic AI. On the upside, agents can reason, act, and even make decisions on your behalf. But on the downside, if you're not careful, those decisions can go wildly off script and sometimes with catastrophic consequences. So how do you help reap the benefits of autonomy without the risks? First, you set clear boundaries. You want to spell out in code and prompts what the agent can and cannot do, right? If your agent should never initiate a payment, make that technically impossible. I think guardrails aren't just some policy that are written in a document and then stored on a drive. They have to be coded technically. Second, you want to keep humans in the loop for sensitive tasks. The idea of fully autonomous agents, I think, is still, it's a great idea, but it's still very immature in terms of the technology that we have today. And you can choose the level of human oversight based on the risk of the task. Think of it like a co-pilot, right? The agent can draft your email, but the human, you, is the one that presses send. And then as your confidence grows, you can loosen the reins. Reiterating what I mentioned earlier, I think it's important to make everything auditable. And I know it's not sexy, but it is something that that kind of transparency builds trust, and not just with your users, but with regulators and auditors too, which are a key area for enterprise. The other thing that you can do is to have an emergency kill switch. Think of it like an end-on cord. It's a concept that Toyota, Amazon have had for a while. And if the agent starts to go rogue, anyone monitoring should be able to pause it instantly or roll back the changes if needed. I don't think this is a nice to have. It's something that you should build in there. And then finally, don't ever lose sight of ethics and compliance, because autonomous agents, especially for enterprise, they have to be aligned with your company policies to avoid reputational and legal risks. So you want to run regular reviews for bias, for fairness, and for policy alignment. If your privacy policy changes, make sure that your agent reflects that. In the end, you want to think of your agent as a powerful but unpredictable team member. You want to empower them, but never give up ultimate control. And Jean-Marc, I know we don't have any more time. I was going to go over the best practices. However, you can actually request a step-by-step AI agent implementation framework directly on my website. And I'm actually working on making that interactive and with a lot of detail, so you can take it and it will walk you through on how to implement AI agents in enterprise. Thank you.
Perfect. Thank you, Anita.
First, I hope everybody can hear me. This has been just a fascinating kind of workshop today, just to hear all the different ways that people are coming at the challenge of agents and some of the opportunity around it. If I could quickly ground people, I think probably what you heard from IBM and what you heard from Salesforce is probably along the same vein that we're going to be talking about over the next 14 and a half minutes or so. LLMware, we launched in open source around 18 months ago. We launched our development framework. And from the very beginning, what we were grounded in was small language models. So you could do a lot of things around RAG and around agents, but it was always how do you do this locally, privately? And rather than think about the biggest model that you could use, we've always been focused on what's the smallest model that you can use. I'm not going to use any PowerPoint. I'm actually just going to show you a demo and really try to bring to life some of the things that we've been doing around agents. Some of our principles, and we mentioned this actually on our last workshop, I guess a couple of months ago. Um, no token charges. We don't like token charges. We don't think they're sustainable. We think the marginal price of inferencing, the market price that people are going to pay for inferencing is going to zero. So get off per token charges because we don't believe that they're ultimately sustainable from an ROI and an enterprise point of view. Second, it can run entirely private. So other than the Zoom link, which is in fact consuming some NPU resources on my machine, so it may run a little bit slower, you can actually run everything that I'm about to show you in an air-gapped environment running entirely on an edge device. Finally, and I think IBM, some of their comments really hit on this really, really beautifully. You can't approach this the same way with a 200 billion parameter model when you start scaling this down to a 1 to 14 billion parameter model. So part of the art of this is how do you think about decomposing tasks and really aligning them so that you can get the best out of small models. Jean-Marc, as you said in one of your earlier comments, basically you can replicate anything that you can do with a big model, you can replicate it with a bunch of small models. All right. What you see in front of me is actually Model HQ. This is our commercial offering that we're going to be launching in about 10 days. This is an overnight build of the code, and we're going to dive right in. And what I want to start off by showing you is just one capability of the product, which is really around document-centric, knowledge-centric, research-centric agent-based processes, again, running entirely privately and locally. The one thing I do want to mention up front that I haven't heard today, and I think it's one of the best kept secrets actually in AI, is the emergence of the AI PC. And this is an initiative that Microsoft originally launched around 18 months ago. Intel, Qualcomm, AMD have been building amazing chips that are coming to laptops soon. This is an Intel Lunar Lake laptop. And again, you're going to see some of the benefits in terms of the performance that you're able to realize, again, locally and on the edge. All right, so these are a few pre-built
Yeah,
agents.
you're not sharing your screen yet. Is that by intent?
Oh no, it actually says sharing screen.
Yeah, I think he's sharing,
Oh,
Jeff.
it's okay, good. All right.
Okay, so you can see my screen. You can see the agent menu, Asif.
Yes, yes, you can see
Okay,
a screen.
all right, good, good. You got me scared. I'm just going to run through a quick process. I'm going to explain the process, show it to you, and then most importantly, I'm going to show you actually how we build it. So this process is one I just built this morning, and it's very representative of what we see as kind of a canonical agent case. You have some inbound, some intake from a customer. It could be a voice transcript. It could be a message that they've left you. It could be an email. It could be a social media post. But you want to take some unstructured text as an input. You want to run it through then a series of analyses to run some intent behind it, sentiment, emotions, and ratings. What's the emotional content of this message? You want to be able to extract and answer some questions. Who is the customer? What is the problem that they have? And then what we're going to do is we're actually, in the course of this process, we're going to take a CSV that's an extract from a database. We're going to build a database table. We're then going to, in natural language, query the database table, pulling information that we've received earlier in the process. You're going to see the whole thing running on the screen, and then we're going to get all the structured output of the analysis of this at the end. All right, so let me go ahead and let's run this. Oops, sorry. All right, this is just a representative. This could have been a voicemail that was left. It could have been an email, customer calling in. chock full of some data points that you want to be able to extract. And also one of the most important things you want to figure out is, hey, is this customer happy? Do they have a problem? Like how urgent, how big of a problem is this? So let's go ahead and let's start running this process. Again, all of this is running locally. And what we're doing is we're actually running 5 small specialized models that are all running on device. They're actually running on the Intel Lunar Lake GPU really, really fast. And each of these are, in effect, we didn't call them action models, but they're essentially action models. They give structured output in response to inputs. They don't work with prompts, meaning all of these essentially are a function that operates on a piece of text and then yields a structured output. We then have 2 services, as I mentioned, the build table and the query table. We're now stepping through the process. We've loaded all of these models in memory. Each of the models then have gone to work on that text input. Sentiment coming in negative, customer is annoyed. On a scale of 1 to 5, customer is not happy with us. We then extracted the customer name and the customer issue. Product isn't working. And then we went ahead and we actually built this table, and I'll actually show how we did that. We built a table of our top customers. We then queried that table with the customer name that we derived in step 5, Susan Sorensen, looked her up in this table that we just created to identify that she's a silver customer and her spend was 112. So thankfully, this is not a big customer, but it does help to complete the process. And something that we see as one of the most common things that people are looking to do, take some kind of input, extract some lookup keys, run some type of secondary lookup then, whether it's a web resource, a RAG resource, or a database, and then pull that information into the context so you can start to evaluate and get a complete picture of it. So at the end of this process, again, all of the keys then are identified, all of the values then that we get from it. And now one thing I skipped over just in the interests of time is this customer happened to include some information that are against our policies. In this case, they included their email, they included their social security. So we've configured on this, the policy, we don't want any of that information. And so actually what was happened is behind the scenes, each of the models read that policy dynamically, redacted that information. So each time a model was called, it was actually redacting that information so that it never went through the model, it wouldn't be promulgated or pushed forward into any other systems. In this case, it's all running on an endpoint device, but if you have this running on a server, you can be certain then that none of that information would get pushed into any other systems. We can see the full inference history and all of the data, each inference, the response, confidence scores where we actually are analyzing the logits and the probability distribution of those logits. We run everything with 0 temperature and 0 sampling, so it's always taking the top logit output from the model. And then you can even see some of the performance characteristics around it. And then finally, we create a whole bunch of artifacts from visualizations of the process all the way down to all of the extract keys that you get at the end, which you can then push through for an API. All right, so that is the process itself. We could keep running this. We could keep running it with new samples. You could picture this running on a whole bunch of different customer support agents' machines. They could all run this process locally without any information leaving their system. All of this is configuration data that's customizable and can be easily shared. But what I wanted to show you, the really cool part, is how you actually build this process. So we actually first built this very simple kind of prototype scenario in LLMware, in open source. There's about 100 lines of code leveraging high-level APIs in LLMware with no UI. Today, it's 8 lines of no code, all running on a point-and-click Windows application. You can download this, run this on your machine, and in minutes, you can be creating these agents with no code. So you could take this process, now that we've created it and run it, you could run it as an API, pop it up to one of our servers, it'll then run it and return the results to you. So if you want to run a batch process, you want to be able to share it. You can then discover other APIs. But what I want to do is I want to go and show how this was created. Now, the way that the underlying agent engine runs, and it's working on this local machine, is everything is, the entire process is represented and generated as JSON configuration. The benefit of that then, again, it becomes really, really easy to export and to share this process. So just as an example, if you wanted to export this, you could build a copy of it. What this does is takes all the JSON configuration, the files that are included in it, packages it up as a zip file. You can do peer-to-peer sharing now because there's no executable code in that package. And there's obviously hash integrity checks done on each of those files. Or you can then easily take this and publish it up to a server so you can then execute and start running this. All of it done privately, locally, and self-hosted by an enterprise. But what I wanted to get into is the code editor. All right. This is the entire process, and this is exactly how I created it this morning. There is no code behind the scene. There is no customization. There are no Docker containers. There are no Python scripts. There's no pip install. Python is not even running on the machine that we are. It's a pure Windows machine, point and click, downloaded, executable. Here is the entire process. We call the sentiment service. As I mentioned, no actual instructions provided because it's an action model that's just giving us a generated output of sentiment and the key that classifies it. It's operating on a context that we define automatically, the stub or framework of we're going to be taking in that text input. That is the main input that we receive. We packaged in a file called customer table 1 that then produces a context. Once we run through each of the sentiment, emotions, rating, the extract model, we extract the customer name, which then generates a variable called customer name. We then build the database table through these two no-code lines, sucking in that CSV file. We infer the schema of it. We put it locally. We create that table as a SQLite database, as sort of a throwaway database running on device. We then query that database. And in querying that database, the longest prompt that we have here is we pull that variable name from this step into a natural language query of what is the customer level for this customer name. That gets converted dynamically into SQL, and then the information is retrieved from that database. We then do that again with their annual spend. So here we are. I know we're running out of time. 8 steps, no code, multiple models, all executing locally and privately with complex lookups across multiple underlying sources. Where we're going with this, this is just one example. There's 35 different services that can be orchestrated in this manner and really, really sophisticated RAG capabilities. So you can start analyzing, parsing, extracting, and manipulating, thousands of pages of information running locally or seamlessly being able to do it in conjunction with a Model HQ server as well. So that is the demo. There's a lot more. I wish that
Yeah, it's an
hopefully this brings
interesting
to life some of the
approach.
things we're working on.
I have one question. You said something about the models directly redact the data, the email, whatever it was, doesn't matter.
Yeah.
Does the model really do it itself, or is it a process after or before the model?
So we have 10 different control points that we implement across all of our model classes within the base code that are fully configurable then by policy. And what that enables you to do then is to set controls at every single step of the underlying model lifecycle. Since it's all self-hosted, it's all running through this code. So if you say, I want to be able to redact certain things, if you say, if this happens, then I want every single model to change its behavior, react in a different way, I want to reroute it from one model to another, all of those can be defined as configurable policies. But yes, it is instantiated as the code, configurable by policy. It's not actually something happening in the model per se.
Okay, got it. I just want to be clear about that. Okay, thank you so much.
Great.
Our next speaker is Anna. She's a product lead for the AI research team at JP Morgan Chase. Welcome, Anna.
Hi, John Mark. How are you?
Terrific. Take it
Great.
away.
All right, I'm going to share my screen. Let me know if you see the main slide.
Go.
Okay, I'm sorry. I need one more minute. All right. I think now you
go
see
again.
the two again. All right. Okay. Thank you all for dialing in. We've had a set of great talks today, and I hope I can still hold your attention for this session where I'm going to be talking about product thinking in agentic AI. I think a lot of the concepts that I'm talking about have been covered before, but probably this is one place where you can understand and see how to build agents with the considerations of building it in enterprise systems, and specifically for industries like finance and banking, where it's a lot of regulation and that happens. Now, standard disclaimer, these are my own thoughts and have no affiliations to the companies I work or have worked with. The statements are forward-looking and may change tomorrow when a new model drops in. And finally, all the slides and content is Gen AI assisted. These days, we have to add the disclaimer for two things. One is transparency, and the other is the more engineers and researchers and product people start using these Gen AI tools and understand as end users, the more we can bring it for the users we build for in the enterprise systems. Okay, so who am I? I am a Napurni, or as Jean-Marc said, Anna. I am a product lead at JP Morgan Chase with the AI research team. Previously, I was a machine learning engineer with Tiffin, which is a fintech startup based out of Colorado and New York, and was a data consultant back in Deloitte. So I have 10 plus years of building systems within the finance industry. And I recently moved to London, if anybody cares. All right, so let's talk about LLM agents, the new opportunities that they bring, the emerging challenges, and what that means for the products that we are building. Autonomous tool use is a key capability, and it's the cornerstone of any agentic system that we're building right now. We want to rely on defined and validated tools and allow agents to use them autonomously. However, we must not disregard that choosing this tool is still a non-deterministic process and it requires oversight. For finance and banking specifically, most processes have at least 2 steps of approval required before any decision making, and we must understand how we bring that determinism into the systems we build. How do we employ the action verification with more than just human in the loop? The next is multi-step reasoning. While a lot of frameworks offer thought, action, and play-by-play of the agent reasoning, decision-making, and planning, it's important that this information is surfaced to the user. And we need to start thinking about a fine balance where we don't have a dump of all the information that of the thought and action versus just giving an answer to the question that the user has asked. The next is that with the persistence of goals and the agent's ability to almost counteract obstacles that it's getting, we are seeing emergent behaviors that are very exciting or problematic. What happens if an agent refuses to abandon a bad plan or takes repeated actions when they are not required? There are costs associated, and then there are unintended risks that we have to make sure that we understand. We need to employ graceful error handling by probably employing bounded goals or interruption mechanisms within the systems that we are building. Finally, most important thing is context awareness. LLM agents are able to keep the history of the actions that they are involved. But as more information is added, what is that point where the information is now saturated and the tools and the goals are misaligned or ambiguous? While guardrails are great, a unique challenge is the trust, which comes in actually 2 forms. One is the system and the other is the user. Can we calibrate our systems in a way that they are trustworthy, that even with additional context and information, they are in the lines of what we want them to have? And the second is, do we trust our users enough that they are inputting information that is valid and that is something that the system will learn from and use? All right, so what exists and what do we need for our domain-specific information? The general frameworks are great, and they are evolving at the speed which is a testament to the rapid innovation that is fueling all of us to contribute and build better systems. And they're great to start with, and what we are seeing is a speeding of prototype building. Previously, prototypes used to take 3 months to 1 year to take what is something out there in academia, in literature, and make it useful within the finance industry. But now the prototyping is within the weeks. The timeline for speeding up, coming up with a useful idea, and actually building has significantly reduced. But what also means is that we have an extended pilot user testing period where we need to understand what are we building, who are we building for, and what needs to happen. There is a lot of specific domain information that exists in finance, business knowledge, which is embedded, or terminology that exists only within the industry. I assume that is also the case for probably insurance or medical industry. And to be honest, there are a lot of solutions and benchmarks out there. The benchmarks that are available are unfortunately not enough to capture the complexities that exist in the real world. So it's very important for us to use something, start with something general, layer on the domain constraints which exist within the industry you're working in, and finally, a very, very important part around governance. I think Anita touched upon that as well. But we need to have industry experts who are actively trying to understand and learn what all this innovation means. What is an agentic system? What is not an agentic system? What is the right level of compliance and controls that does not stifle innovation? So it is important that for us as AI researchers, as ML developers, that we bring the compliance, bring the regulators, the legal, the regulatory authorities within the conversation of what we are trying to build. It's not only important for us to tell them what and why of the build, but also the how. It is easy for them these days to understand because large language models have made it easier for us to grasp very complex information. So it's important that when they appreciate what we are building, it's going to make an environment where we are operating from a space of caution, and yet we are innovating at the speed that we need to innovate on. All right, so what do we need from the agent frameworks that we require in the enterprises? Now, memory, most agent frameworks have them. There is long-term memory, there is short-term memory, there is some form of episodic or session memory. But what we are seeing while interacting with the users is that we need to be able to edit memory. Now, what does editing mean? It means the flexibility of having a memory that can work with the users. So it goes back to the point of giving the users the agency while still calibrating with trust. Having an editable memory with controls obviously gives more confidence to the enterprise users that the agent memory is flexible and not monolithic and allows for change. The next is meta reasoning, where the agent actually self-reflects on the strategies that it's taking. There are solutions, for example, agent as a judge, where you have an external agent understand the actions that it takes, but having the agent self-reflect also goes back to the point of what I was talking about, a second layer of approval. Probably the agent reflects, understands, and we can have another layer to verify what it has built. Next is debugging interfaces. And to be honest, I am seeing a lot of products out there which are helping with understanding decision process. So it's interesting to see what's out there and what's helping the agent developers actually understand what's happening. And the finally most important part is real world integration. Now, MCP servers are great. That's what we needed in the next level for us to go from these agentic frameworks to actually integrating these. But legacy systems are still a big problem. Or the fact that they are entrenched within the industries that we are working with makes it a problem that we all need to solve and not something that we let go of. So we need to understand how we will have real world integration for applications and legacy systems that exist within the industry. So what am I trying to tell you? I'm trying to tell you that when we are building these agent workflows, when we are deciding whether we need a single agent, whether we need a multi-agent, what is the role of these agents that I need to describe, what is the description, we need to have a human in the loop as the design principle. We can argue that we can limit and scope this system of what we build, but the user should have the final decision on what needs to happen, at least for the time that we are building trusts with the system that we are. And to make sure that the user has the information for them to take the final decision, we need to make sure that the systems are explainable, that the systems are surfaced with, the user is surfaced with information that is important for them to make the final decision on what needs to happen. The next is configurability, the ability for the users to know that the system is flexible such that they can adjust the automation level. They can take control when they want to, they can give back control when they feel that the system is confident enough and they trust it enough to make the right decisions. And finally, recoverability. Reversal of agent actions is also something that's coming up, where we have made a system, we're confident it has taken a decision, however, we want to go back to the previous state. It exists within the agent frameworks of going back to the state, but giving the user the control of recovering from a previous step is important. So explainability, configurability, and recoverability are some design principles that we need to think about. Okay. Now, how do we think about building agent systems and what mindset should we have? Systems thinking is where we need to have not a linear flow of what we build, not step one, step two, step three, but almost this continuous feedback loop that adds in information from the parties that your system is using, getting information and input from. We have to consider emergent behaviors. That is something that's coming up, and with agent use and large language models, we have to make guardrails and controls around it. So we have to design loops rather than linear flows. We have to design integration cycles rather than individual components. The next is co-designing with users. Now more than ever, we need to build systems with the users. I would say up until even a year ago, we would build prototypes, have the users test and validate, and now we would take back. Then we would take back what we need to build, what features we need to add. But now with the rapid innovation and not enough evaluation and benchmarks, as I alluded before, the human validations becomes your most trusted source of information for the agentic systems we are building. Users have to be thought as your design partners. We have to understand that bringing in the user right now is where we add most value to the agentic systems. The technology is existing, it's evolving, it's rapidly being used. How do we make it usable is where the users come in, and which is what I'm reiterating here. Next is the ambiguity. Now, this is also something that I think Anita mentioned, but we are no longer using the machine learning models where you have an input and you have an expected output where you can validate it with the ground truth. Right now, an agent could build a 4-step plan, or it could build a 5-step plan, which essentially does the same thing. How do you convince your leadership and how do you convince your users that the variability that exists with agentic systems is something that they need to be comfortable with? Again, having the users within your initial builds builds the confidence with the users on what they are seeing, what they can expect, and it also recalibrates them, because right now all of the enterprise systems are built upon accuracy. That is the number one metric that we are looking for. How do we take that concept and then separate out and bring in the uncertainty that comes with and build to make sure that all of us are comfortable with what we are building? And finally, we have to understand that it's not just agent building. We need tools, we need orchestration, we need UX for trust, and we need prompt engineering for making these cross-functional teams that work on building an agentic solution right now. So finally, 3 things. One is most agentic AI systems are right now succeeding when we are enhancing human capabilities. Systems which are trying to replace humans are not allowing for the key user or the key understanding of how these systems are built. Like I said, it might change tomorrow, but today we have to have augmentation focus on what we are building and how we add value to the enterprises. The next is the design balance between system design, between technicality, and between user needs. This has existed before in product, but now the balance has to be maintained for something that's rapidly evolving. And the third is that the trust and adaptability should be foundational, not an afterthought. This is also something that for a system and enterprise level system which is regulated is important for the users and for us to understand when we build it. I think I'm on time.
Perfect timing. Perfect. And this was really, really insightful coming from a large bank and understanding the constraint that, to your point, apply to healthcare as well and other industries, and seeing how to resolve that. Thank you so much, Anna.
Absolutely.
And
Thank you.